start with our first chapter, like in our discussion. What is the first chapter? There is nothing but the basic concepts. Okay, so we will start with the first question. What is the definition of surveying? There you go. You have done surveying 1, you have done surveying 2. Right, all of that is over. Right, surveying 1 lab also you have done, surveying 2 lab is also done. From this, can you please tell me what is the definition of surveying? What is the definition of surveying? Right. So I'll not keep chat on, because if chat is kept on, everybody will keep on getting notification. You can send your questions in Q&A. Okay, I'll be keeping the Q&A open. Okay, so you can send questions in that. Okay, right. Anyway, it will be nothing but yes or no questions only. You have doubts, I will clear all of your doubts at the end of the lecture every day. Okay. One more suggestion I can keep is keep a white piece of paper with you. Like, keep a white piece of paper with you. Whatever doubts you are having, write it down on that white piece of paper. At the end of the class, you can ask. Okay. Secondly, I am going to send the PDF of the notes after the class. So you need not write the theory. Write only the formulas. Because once I discuss a formula, I will be solving a problem on that. The formulas लिखने के लिए notes रख दो. Okay. If you write it very neatly, this can be your formula book for revision also. Okay. So 2 to 3 things you can simultaneously finish if you listen to the class. Notes anyway, I am giving you formula books. You can prepare while you are attending the class. Whenever you are having doubts, write it in a piece of paper. At the end of our lecture, I will definitely give you time to discuss the doubt. Right. So anyway, right. What is the definition of surveying? Can you please tell me? Anybody? What do you mean by the definition of surveying? Surveying is defined something like this. It is the art and science of expressing the relative positions of objects. What is surveying? Art and science of expressing the relative positions of objects lying just above, just below, or on the surface of the earth. Okay. Art and science of expressing relative positions of objects lying just above, just below, or on the surface of the earth. This is what we call it as our survey. Okay. Now, what do you mean by the term relative? What do you mean by the term relative? See, relative means with respect to something fixed. Right. You call your uncle, you call your auntie as a relative. Your uncle is obviously your relative. Your auntie is obviously your relative. Why do we call them as a relative? Because they are people who come into our life with respect to our mother and father. Correct now? We have mother and father. With respect to mother and father, these people, whoever we get in our life, we call them as a relative. So mother and father fixed. With respect to fixed mother and father. Anybody say mother and father not fixed? Big fight will start. So no doubt, mother and father is fixed. Okay. With respect to fixed mother and father, whoever we get in our life, we call them as relative. Okay. That is the idea. Right. So let us try and take this example in terms of survey. Okay. So you imagine this, that this is a portion of a city. Like, you just imagine that this is a portion of a city where I'm having this example in terms of survey. Okay, so you imagine this, that this is a portion of a city. Like, you just imagine that this is a portion of a city where I'm having my first friend standing here. Imagine that I'm having a second friend standing here, followed by another third friend who is standing there. I need to express the position of the second friend and the third friend with respect to my first friend. We'll keep the first friend as fixed reference. Okay, and with respect to that, I need to find the position of my second and my third friend. Okay, so what will I do? First and foremost, I need to say at what distance am I having my first friend. Where do you think I'm having my first friend? My first friend is at a, like, let us say, a distance of, say, 5 meters from me. Okay, right. And my second friend is at a distance of, say, something like 10 meters from me. Okay, so this is how you express their position. 5 meters from the first position, I have the second friend, and 10 meters from the first position, I have my third friend. Right. What do you call this 5 meter and 10 meter? What do you call this 5 meter and 10 meter? Please understand, this 5 meter and 10 meter is what we call it as the horizontal distance. 5 and 10 is what we call it as horizontal distance. Okay, now, right. Next, whenever I'm taking these two horizontal distance, can you see an angle forming in between them? Yes or no? Yes. Very clearly, you can see that there is an angle forming between them, something like this 60 degree. An angle is forming between them, an angle of 60 degree. What do you call this angle as? You call this angle as horizontal angle. Call this angle as what? Horizontal angle. Okay, right. Now, is my first friend, second and third friend are on same level, or are they on different levels? They are on different levels. Clearly, now you can see the three friends are not on the same level, they are on different levels. Okay, so what is the level difference between my first friend and the second friend? The level difference between the first and second friend is, say, something like 3 meters, and the level difference between the first friend and the third friend is something like, say, 9 meters. Something like 9 meters. Okay. Now, what do you call this 3 meter and 9 meter in our survey? We call this 3 meter and 9 meter as, you see, vertical distance in survey. We call it as what? Vertical distance in survey. Now, like, due to this particular vertical distance, right? If my friend 1 wants to look at friend 3, how he needs to look? Can he look horizontal like this? Yes or no? No. If he looks horizontally, can he see my friend? No. He cannot look horizontally. He needs to look slightly up like this. So when he's looking up, he's putting one more angle here like this. One more angle of, say, something like 30 degrees like this. What do you call this particular angle as? In our surveying terminology, we will call it as the vertical angle. Call it as the vertical angle. That's it. Okay. So these are what we call it as the 4 basic measurements of surveying. So please remember, whenever we are getting these 4 basic measurements of surveying, I can say that my entire measurement is or my entire surveying is completed. Okay. So हमारा first front fixed है, तो ये fixed front के हिसाब से with respect to this fixed front, we are trying to find the position of second and third front. Right. That's why we call these positions as relative positions. Okay, na? And our points under study, that is 2 and 3, they may be on the surface, they may be above the surface, or they may be even below the surface. Right. And to find relative positions, you need these 4 basic measurements in survey. Number 1, horizontal distance, horizontal angle, vertical distance, and vertical angle. Right. Let me ask you a small question. Please try and answer this. What was the first survey you did in your surveying lab? Please tell me. What was the first survey you did in your surveying lab? Please tell me. What was the first survey you did in your survey lab? Right, very good, very good. Right, absolutely correct. Everybody giving me the correct answer. But this is my question. While doing chain surveying, out of these 4 basic measurement, which one did you get? While doing that chain surveying, out of this 4 basic measurement, which one did you get? Chain survey gives you what? Which basic measurement? Gives you which basic measurement? Very good. It gives you horizontal distance. So right, while you are doing chain surveying, we were teaching you how to measure the horizontal distance in surveying. Okay. Now tell me, right, what was the second experiment in your surveying lab? What was the second experiment in your surveying lab? After chain survey, what you did? We did compass surveying. Very good. Absolutely correct. Abhi batao, right, compass surveying is giving me which parameter? Compass survey is giving me which parameter? Which basic measurement here? Right, very good. It is giving me the second one, which is nothing but the horizontal angle. Right. So once we discussed about how to measure horizontal distance, we discussed about how to measure horizontal angles by using an instrument known as compass, and the survey is known as compass survey. Now tell me, to get vertical distance, what was the surveying that you did? Vertical distance, right? To get the vertical distance, what was the surveying that you did? Anybody? Like absolutely correct. You're giving me the answers very, very clearly. Very good. We call it as a leveling. Dumpy level, auto level, leveling staff, back side, foresight, intermediate side. All of that comes in the vertical distance only. Now tell me, to get vertical angle, what was the survey you did? To get vertical angle, what was the survey you did? The name of the instrument is what we call it as theodolite. Absolutely correct, right? And the survey is known as theodolite survey. The survey is known as theodolite survey. That's it. So please observe this. How do you think the surveying lab is designed? The surveying lab is designed in such a way that each and every basic measurement is introduced to you simultaneously. One by one, right? Each and every particular basic measurement is introduced to you. Understand? Now let me ask you, right? If I'm using a total station in the field, out of this 4 basic measurement, which one do I get? Out of this 4 basic measurement, which one will I get if I'm using a total station? Yes, very good. I'm going to get all the 4. So I'll get all 4 measurements like this. Okay, right. So this is how our surveying lab is designed. Okay, right. So one by one, each and every basic measurement is introduced, and then right, a combination of all of them is introduced by using our total station. Right. Now let us discuss what are the objectives of doing survey. Right. What are the objectives of doing survey? Please remember, there are in fact 3 main objectives of survey. Starting with number 1 is to prepare maps and plans. Please remember, whatever surveying you are doing, the end result of all the surveying is nothing but a map or a plan. Think about your chain surveying. You take your chain, go to the field, measure offsets, record everything in your field book, come back to the lab, make a figure, right? Take a white piece of paper and make a figure of whatever you measured in the field. Keep this figure give this particular figure to your teacher. What do you call this figure as? You call this particular figure as the map of the area or the plan of the area. Think about your plane table survey. Say you do the entire work. Finally, the paper you submit to your teacher. What do you call that paper? You call it as the plan of the area or the map of the area. If you don't remember any of that, just look at this. So this is an isometric view of a room. If I give you the chain or a tape, can you able to measure this distance? Yes or no? Yes, you can clearly measure this distance as something like say 5 meter. You can measure this distance as something like say 10 meter. Can you represent this 5 meter by 10 meter on a piece of paper? Can you measure this 5 meter by 10 meter on a piece of paper? Yes, we can do that. What will I call this as? I will call this as the plan of the room. I'll call it as the plan of the room. Now, why do you want to calculate the plan of the room? Why do you want to draw the plan of the room? Because we need to calculate areas and volumes. Okay. So if these dimensions are known, tell me what is the area of the room? area of the room is 5 into 10 meters square. If I'm saying that the average height of a floor is 3 meter, can you calculate the volume? Yes, we can calculate volume also. Area into height will give me the volume. So please remember, the first job of every survey is to prepare a map or a plan. After preparing this maps and plans, what do? You immediately calculate the areas and volumes. Okay, right. And finally, what is the last job of the surveyor? It is to set out the proposed civil engineering work. That is the last job of the surveyor. To set out the proposed plan onto the field. The process of putting the plan from the paper to the field is what we call it as setting. Okay. So I hope you have seen. So for example, if you imagine that this is the boundary of your building, boundary of your property, right? To put a plan on this particular property, what the surveyor will do? He will come to this field. He will take a wooden peg. He will drive the wooden peg here like this. He will drive the wooden peg here like this. He will drive another wooden peg like this. Now he will take a white thread and he extend the thread like this. White thread and he will extend the thread like this. Similarly, right? He will drive one more wooden peg here, one more wooden peg here, another wooden peg here. Extend the white thread like this. Right? Extend the white thread like this. Now, can you please tell me what is the intersection of these two white threads will represent? What is the intersection of these two threads representing? It is going to represent your column position. Say C1. First column position C1. Okay, first column position C1. So this process of representing the positions of columns, right? Center line of the brick in the field is what we call it as setting out. Okay. So when this particular process is completed, who will come to the field? Once the setting out process is completed, who will come to the field? The JCB will come to the field. They will start doing excavation. The JCB will come to the field and they will start doing the excavation. Understand? Yes. Okay. So that is what our surveying is all about. Okay, you first go and do survey of the area and prepare the maps and plans. Once you prepare the maps and plans, you calculate the areas involved, the volume of earthwork involved, all these calculations you do, right? And number 3 is to set out the proposed plan of the field. Whenever you are having the plan, you need to put it in the ground. Once that is completed, construction will start. So if you go and look at any building in the world, what is already completed there? Surveying has already been completed there. That is why we are able to construct. Without surveying, we cannot start our construction. Yes, that's it. So that is about the objectives of something. Now, let me just tell you the brief history of survey. What is the history of survey? See, what was the first type of engineering that started? See, it's absolutely not important for you. Just listen. History means nothing but story. Okay, so please tell me, what is the first type of engineering that started? Obviously, it is nothing but civil engineering. Right now, see, if I'm asking the question to a classroom of civil students, obviously the answer is civil engineering. So, the first engineering that started was nothing but civil engineering. But it started with what? Right? Military. I know, before military, people used to live, right? Surveying was there, right? So, the first surveying was nothing but our, civil engineering. And the concept of civil engineering started with what? With the discovery or with the idea of a home. With the idea of a house. Okay, that's when civil engineering started. Now, the question is, who, brought the idea of this particular home? See, the idea of home was first conceived by our cavemen. So, who are cavemen? What do you mean by cavemen? Very simple. The people who lived inside cave. That is what we call it as cavemen. Okay, right. So, whenever it was raining heavily, whenever it was snowing heavily, whenever it was too hot outside, or whenever it was too cold outside, the people needed shelter. So, they went inside cave and they took shelter in that cave. We call them as cavemen. Okay, we call them as cavemen. So, you imagine that you are a caveman, and it is night 12 o'clock. It is raining very, very heavily. Thunder is there, lightning, everything is there. So, you are taking shelter inside your cave. At that moment, you imagine another caveman tries to come inside. Your cave. Will you allow him inside? Yes or no? Tell me, will you allow that person to enter into your enter into your cave? Yes or no? Will you allow that person at night 12 o'clock to enter your house? The answer is no. Right? Why no? Why did I say the cave man? I did not say cave woman. Night 12 o'clock, some man tries to come into your house. Will you allow him? No, we will not allow him. Right? We will not allow, yes, strangers to come into our house. So we'll say, do not come, this is my house. Correct? I'll say, I don't come inside, this is my house. This is my cave. So what you are doing is, you are forming an imaginary boundary and you are taking ownership of that land. That is when actually surveying started. Okay, that is when actually, truly speaking, surveying started. The Egyptians used the same concept and said, okay, if you want this much piece of land, you give me this much amount of money. What is that? That is land tax. Okay, so the taxation, everything came when people started to legally own, when people started to legally claim ownership of land. So how do you find boundaries of this land? By doing surveying. But this surveying became a practice in engineering only by the time of Romans, because the Romans built the first roads. Understand? So for building road, obviously you need to do surveying first, right? So the Romans, incorporated surveying as part of their engineering practice. From there on, we are having surveying. Right? The first distance measuring instrument in surveying was invented by Archimedes. We know Archimedes now? Yes, we definitely know Archimedes. The same Eureka fellow. He invented the first instrument for surveying, which was basically a distance measuring instrument. From that distance measuring instrument, we came up with compass to measure angles. Right? Then we started using levels, dumpy level, auto level, theodolite. Right? Now we don't use any chain, compass, or anything. Nothing we use a total station. But the problem with the total station is that it cannot be used to cover large areas. It can only cover small areas. So larger areas covered area, we started sending aircrafts into the sky to take photographs. We call them as aerial photogrammetry. But this aerial photogrammetry is a very costly affair. So to reduce the cost, we have sent cameras permanently into the sky. Okay, Okay, what are these cameras in the sky known as? Satellite, which is nothing but our GPS satellite. So this is the history of surveying, right from caveman up to our satellite system. Okay, that is the history of surveying. Now, just like I told you, history means nothing but story only. Whatever I told you is there in the material. Obviously, caveman and all is not there, but remaining information is there in the material. Just go to that. Okay. So now, what we will discuss is regarding our Earth. What we need to discuss is regarding our Earth. Okay. So tell me, what is the shape of the Earth? Tell me, what is the shape of the Earth? Do you think the Earth looks exactly circular like this? Yes or no? The answer is no. Because please understand, the Earth has an axis of rotation. The Earth has an axis of rotation, and the Earth will always rotate about that axis of rotation only. Tell me, what happens when anything rotates? Can you tell me? What happens when anything rotates? Right? What happens when anything rotates? Centrifugal forces are generated. Correct? When we enter into a curve, when we try to enter into a curve, centrifugal forces are generated. And how does these centrifugal forces act? They will act outwards like this. So centrifugal forces will start to act outwards like this, and due to this particular force, what will happen to our Earth? The equatorial regions of the Earth will start to bulge out like this. You see, equatorial region starts to bulge out like this, right? But the polar regions will get flattened like this. This is how it should look like. But as the Earth rotates, centrifugal force will push equatorial region outwards, and it will make our polar regions flatten. What is the shape known as? This shape is mathematically known as oblate spheroid. This shape is mathematically known as oblate spheroid. It is flatter at the poles and it bulges out at the equator. So please look here. In the poles it is flat. In the equator it is bulging out. Right. So we will have definitely two different values of diameters. I think you can agree. From pole to pole we'll have one value of diameter, and from equator to equator we'll have another value of diameters. So complex dimensions will be there for Earth. It is observed that the polar diameter of the Earth is the polar diameter of the Earth is 12713.8 kilometers. 12713.8 kilometers, right? And the equatorial diameter of the Earth is the polar diameter of the Earth plus 42.95 kilometers. Okay, so the equatorial diameter is greater than the polar diameter by how much? 42.95 kilometers. So this is the complex coverage of the Earth. But please remember, for all calculation, what is the radius of the Earth taken as? Radius of Earth, capital R is equal to how much? 6370 kilometers. Radius of your capital R is equal to how much? 6370 kilometers. So these values are absolutely rubbish. These values are absolutely rubbish for GATE students. GATE students need not study this. Okay, such a numerical values, just some data is not important for GATE preparation point of view. But if you are a PSC level preparation, if you are doing for a PSC level preparation, then only these data are important for you. GATE people just don't mug it up. Just leave it. Ignore it. Shape क्या है याद करो, right? ये radius क्या है याद करो बस. Just remember what is the shape. Just remember the radius value. That's it. Okay. The other details you just simply forget. I'm sorry. Sometimes I'm saying some Hindi words because of my last class. That was for a Hindi batch. That's why this Hindi is now. Just give it 2 days. It comes back to full English. Okay. So I'll not teach in Hindi or anything. I'll be taking in English only. Okay. But the last class was last week was having Hindi lecture. That's the reason why little bit Hindi is coming. Okay. But give it time. 1 or 2 days it will be normal. Okay. Yes. So that is the dimension of the Earth. Okay. Yeah, that is the dimension of the Earth. Okay. So you see the shape of the Earth is what we call it as oblate spheroid. It is flatter at the top and bulges out at the equator. The same points what will be discussed. Yes. Now we'll talk about the primary divisions of survey. What are the primary divisions of survey? Can anybody please tell me? What are the primary divisions of survey? Anybody please tell me what are the primary divisions of survey? At least how many are there? Anybody? Come on, answer. Yes, very good. Little bit difficult to chart in 4. Don't understand that. I mean, like in Q&A you are finding it difficult. Maybe that's what you're saying. Okay, yes, very good, Ananya. The correct answer is plane and geodetic survey. So there are two divisions of surveying. It is nothing but plane surveying and geodetic survey. So, what do you mean by plane surveying? What do you think is plane surveying? Just tell me. What do you think is plane surveying? Please tell me. What is plane surveying? What do you mean by plane? Yeah. What do you mean by plane? Plane means it is flat. There is no curvature. Plane means it is flat. Right? Earth's surface is flat and it is no curvature. Right. So that is the first understanding of plane surveying. Plane surveying means the curvature of the Earth is not considered. What did I just tell you? Just 2 minutes before, I told you that the Earth is having complex curvature. Right? 2 minutes before, I just told you that the Earth is having complex curvature. From equator to equator, one value of curvature. From pole to pole, another value of curvature is there. But what is this plane surveying saying? He is saying that there is no effect of curvature. Right? And what will geodetic surveying say? Geodetic surveying will assume that curvature of the Earth is considered. Can you please tell me how far is the assumption of plane surveying valid? Plane surveying says that Earth is having no curvature. My question is, how far is this assumption valid? Is this assumption valid for a large extent of area, or is this valid only for a smaller extent of area? Right, it is valid only for smaller extent of area. Right, it is valid only for smaller extent of area. Understand? Yes. Right. So, if you, for example, if you go and stand in your college cricket ground, you don't feel the curvature of the Earth. No, you don't feel any curvature of the Earth. But if you go and stand on a beach, if you look at the the ocean surface, you don't feel that it is flat. It will have a certain degree of curvature. Understand? Yes. So please understand the assumption that the Earth is having no curvature is valid only for smaller extent of area, and geodetic surveying is used for larger extent of area. So the important question here is, what is the limit up to which this is valid? The important question is, what is the limit up to which this particular assumption is valid? Please remember, the assumption that the Earth is having no curvature is valid only for distances less than 12.5 kilometers and areas less than 195.5 kilometers. Some of you will say that distance is 18.5 km and areas are less than 250 square kilometers. That is not the presently adopted values. If you take any standard textbooks that are published after 2016 and all, you'll see that they have used the value of 195.5 km square or roughly 200 km square, and the distance limit is kept as 12.5 km. So whenever the areas and distance covered are less than 12.5 km and 195.5 km square, the type of surveying that we should consider is plain surveying. If the distances are exceeded or areas are exceeded, we will classify it as geodetic survey. So the question is, why only 12.5 kilometers? What happens if I take a value more than 12.5? Let us take a small discussion and understand that. So you imagine this is the surface of here. Like you imagine that this is the surface of here. This is the curved surface of here. Just imagine. And what we will do is we will take 2 points on this surface, A and B. There are 2 points on the surface, A and B. I have taken A and B in such a way that the arc length AB is equal to 12.5. What is the arc length? The arc length AB is 12.5 kilometers. Okay, the curved length AB is 12.5. Now I want the chord length AB. What do you mean by chord length AB? What do you mean by chord length AB? It is nothing but the straight line distance AB. Chord AB is nothing but what? The straight line distance AB. Can you please tell me what will be or who will be greater here? Arc will be greater or chord will be greater? Arc will be greater or chord will be greater here? Who will be greater? Very good. Arc will be greater than the chord. Now the question is, for distances up to 12.5 km, what is the difference between the arc and chord? The difference between arc and chord is only 1 cm. The difference between arc and chord is only 1 cm. So you see, on the surface of the earth, if I take 2 points A and B, which is at an arc distance of 12.5 km, now if I measure the chord, the straight line distance between the 2 points A and B, it is seen that the difference between this arc and chord is only 1 cm. Arc and chord varies only by 1 cm. Now please tell me, compared to 12.5 kilometers, is the 1 centimeter a large value or a small value? Compared to 12.5 kilometers, 1 centimeter is a large value or a small value? It's a very, very small value. It is a negligible value. It is a negligible value. So can we neglect it? Yes. So if you are neglecting it, you are saying that arc length AB is equal to chord length AB, which means no effect of curvature. Which means there is no effect of curvature. Yes or no? So if you are neglecting that 1 centimeter difference between arc and chord, you are saying that arc length is equal to chord length, which means the earth's surface is flat. So this is the reason why we will limit the distance as 12.5 kilometers. Now why the area of 195.5 kilometers? Let us understand that. So consider the earth surface like this. So this is our earth surface, okay, or the actual earth. Now we will consider 3 lines on this earth. So this is my first line. You can see that it is a curved line. Okay, obviously it will be curved. This is my second line. Obviously that is also curved. And this is my third line. Obviously that is also curved. So I have taken 3 curved lines or 3 lines on the surface, which will be obviously curved. They are meeting at points here A, B, and C. So the 3 arcs are meeting at A, B, and C. Does ABC look like a triangle to you? Yes or no? Does ABC look like a triangle to you? Yes or no? Yes. It does look like a triangle. It does look like a triangle. Yes. But tell me, does the triangle having straight sides like this? No. The triangle is not having straight sides. If there are straight sides, I will call it as plain triangle. If the triangle is having straight sides, I will call it as plain triangle. But this triangle is having curved sides, you see. This triangle is having curved sides like this. Okay. So what do you call this resulting triangle as? This curved sides are there. So you call this particular triangle as, you see, a spherical triangle. You call this triangle as what? Spherical triangle. What do you call this triangle? Call this as the spherical triangle. Right. Now, for a plane triangle, please tell me, for a plane triangle, what is the sum of the angles? What is the sum of the angles? For a plane triangle, the sum of the angles is what? 180 degree. Right. But for a spherical triangle, please remember, the sum of the angles is not equal to 180 degree. But in fact, it is more than 180. Okay, the sum of the spherical angles of a spherical triangle, the angle goes spherical angle कहता है. Spherical angle A, spherical angle B, spherical angle C. Plane triangle के लिए plane angle A, plane angle B, plane angle C. Spherical triangle के लिए spherical angle A plus spherical angle B plus spherical angle C. What is the sum? The sum is, you see, more than 180. So I'll write like this: 180 degree plus E degree. I write it as 180 degree plus E degree. What is this E degree known as? This E degree is known as the spherical axis. What is the E degree? E degree is what we call it as the spherical, okay, axis. Right. Now, please remember, it is observed that when the area covered by this triangle is less than 195.5 km square, when the area covered by this triangle is less than 195.5 km square, what is the value of the spherical axis? Okay, now write them once again. So if the area covered by this triangle is less than 195.5 km square, what is the value of the spherical axis? Please remember, the value of spherical axis will be equal to only 1 second. The value of spherical axis becomes equal to only 1 second. Like that means spherical angle A plus spherical angle B plus spherical angle C is equal to 180 degree, 0 minutes and 1 second. 180 degree, 0 minutes and 1 second. Now compare the 1 second with 180 degree. Is it a large value or small value? Absolutely small value. Absolutely small value. So can I neglect it? Yes. So if you are neglecting that 1 second, you are saying that spherical angle A plus spherical angle B plus spherical angle C is equal to 180 degree, 0 minutes and 0 seconds. What is the meaning? It is nothing but a plane triangle. Yes. So if you neglect that 1 second, the spherical triangle becomes equal to what? Plane triangle, which means there is no effect of angles. Yes. So these are the reasons why we keep the limit as 12.5 kilometers and 195.5 kilometers. That's it. Okay. So that's it. That is the comparison. That is it. Discussion regarding our plane surveying and our geodetic survey. Let me ask you some more. questions. Okay, you please answer. Okay, tell me who is more accurate, plain survey or geodetic survey? Who is more accurate? Please tell me. Who is more accurate? Is plain surveying or geodetic surveying more accurate? No doubt. No. No, Harikiran. Who is more accurate? Geodetic is more accurate now because plain surveying is neglecting things. Yes, very good. Chandana, very good, Praveen. Right, plain surveying is neglecting few things, but geodetic surveying does not neglect anything. Therefore, geodetic surveying is more accurate. Who will cover larger area? Plain surveying or geodetic surveying? Who covers larger area? Who covers larger area? Obviously, geodetic surveying covers larger area. So no. Yes. Tell me, what are the angles of a geodetic triangle? ABC angle. What did we call these angles as ABC and all? We call them as spherical angles. We call them as spherical angles. So in geodetic surveying, all angles are spherical angles. But in plane surveying, what are the angles here? The angles. What do you call these angles as? We call these angles as plane angles. So in plane surveying, all angles are plane angles. In geodetic surveying, all angles are spherical angles. That's it. One last point that we need to discuss is regarding the direction of gravity. That's the last discussion. Okay. So please tell me something. Right? If I drop this pen from this point, how does the pen will go? The pen will go like this. Right? If I drop the pen from here, how does this pen go? The pen will go like this. Okay. So this is the direction of gravity at this point. This is the direction of gravity at this point. How are these two directions of gravity? Are they parallel to each other? Absolutely yes. So in plane surveying, the next point you should understand is the directions of gravity are always parallel to each other. The directions of gravity are always parallel to each other. Right? But in geodetic surveying, is that true? Let us see. So you imagine I'm having a friend here on the surface of the earth. Standing here, he will drop one pen. Standing here, he will drop one pen. How does the pen go? The pen will go like this. So this is the direction of gravity. Now imagine I'm having another friend standing here like this. He stands here like this and he drops a pen. How does the pen go? The pen will go like this. What is this? Direction of gravity. I'm having another friend here like this. Standing at this position, he drops a pen. How does the pen go? The pen goes like this. This is the direction of gravity. So look at the three directions of gravity in our geodetic survey. Tell me, are they parallel to each other? The answer is no. They're not really parallel to each other. But how do they act? They act such that they are converging to the center of the earth. They act such that they are going to converge at the center of the earth. So you see, right? That is the last difference. Okay. Let us put all of the points together. So tell me, plane surveying is less accurate, geodetic surveying is more accurate. Directions of gravity are considered parallel to each other in plane surveying. Directions of gravity are converging to the earth center. Next point, what was the last point here? All angles are plane angles. All angles are plane angles. All angles are spherical angles. Right. So that's it. That is plane surveying and geodetic surveying. So these are the differences between. That's it. Yeah, there was some problem with the video. I think now it's rectified. Okay, right. So these are the main differences between plane surveying and geodetic surveying. This particular question was asked in multiple times. Multiple times. The comparison was asked in engineering services as well as in our GATE examinations. GATE has now introduced very recently multiple select questions where they can explore different theoretical questions. Like they can now explore different varieties of theoretical questions by using that multiple select questions. So it is not that you can completely ignore theory. That will be dangerous. Don't do anything like that. You need to have some fundamental understanding of the theory. Okay, so that point you please keep in your mind. Yeah. Okay, so that's it. That is a comparison between our plane surveying and geodetic surveying. Right. So while talking about plane surveying, geodetic surveying, we discussed now one arc length, chord length, what's the limit? We'll just write down the discussion here. Arc length and chord length varies only by 1 centimeter. Okay, right. So these are the reasons why we keep the limit as 195.5 kilometers per and 12.5 kilometers. That's it. Okay. So that's it. Right now we'll discuss about the 195.5. Kilometers per and 12.5 kilometers. That's it. Okay. So that's it. Right now we'll discuss about the principles of survey. So the next topic that we'll discuss is regarding the principles of survey. So you might remember, yes or no? This is the first question your external is going to ask you. Right now, this is the first question your external in the Viva examination. They will come and ask you, what are the principles of survey? How many principles are there? Can anybody please tell me what is the first principle of surveying is? Okay, Praveen. Whatever I write in the board, everything will be there. Okay. Whatever I write in the board, everything will be there. Okay, don't worry. Okay. Yes. Very good. Again, the correct answer is the first principle of surveying is to work from pole to part. The first principle of surveying is what? It is to work from pole to part. Okay. Yes. So tell me, why do you need to work from pole to part? Tell me, why do you need to work from pole to part? What is the reason you are working from pole to part? Please tell me. Give me an answer. I'll just come back. So, yes, parallelism, no, errors, minimize the errors. So, Manish says that it is to minimize the errors. Okay. Now, the terminology is not minimized. Yes, my answer is correct, but the correct terminology is not minimize the errors. The answer is it is to localize the errors. It is to localize the errors. Okay, right. So, please remember, when we work from pole to part, what is going to happen is the errors are going to get localized. The errors are going to get localized. What do you mean by localized? Localized means it will remain in only one part of my measurement. If at all there is an error in a particular measurement, it will be present only in that part of the measurement. Okay, it will not go and affect the other parts of the measurement. That is the meaning of localized. Now, if I work from part to pole, what will happen is there will be accumulation of error. If I work from part to pole, there will be accumulation of error. What do you mean by accumulation of error? It means that a small error in the beginning will keep on accumulating to become a large value or a large error at the end of the sum. That is what we call it as accumulation of error. Okay, so Please remember, while we are working from whole to part, errors are localized. Means if there is an error in one particular measurement, it will not affect the next measurement or it will not affect any other measurement coming after it. But if your instrument is, if you are working from part to whole, then there will be accumulation of error, which means an error of 1 mm in the first measurement will keep on accumulating, adding, and at the end of the survey, the error becomes too large. The error becomes very large for us to close this error. That is what is meant by accumulation of error. Understand? Yes. So let me write down. Right? You might remember a figure like this. Yeah? When you first came across this particular principle, you might have seen a figure like this. This is the area to be surveyed. Working from whole to part means first you establish primary triangulation points around the area to be surveyed with high accuracy. Okay? With high accuracy like this. Next, what do? You divide this primary set of triangles to secondary set of triangles like this. Okay? Now divide the secondary set of triangles to tertiary triangles like this. Right? So this is what you call it as working from whole to part. You start from the boundary and you work inwards. You start from the boundary and you start working inwards. That's it. Okay? Right? So let me write down. Prevents its accumulation. Okay, please remember that. Working from whole to part localizes the errors. The terminology yaad rakho. Please remember the terminology. Like working from whole to part localizes the errors and it will prevent its accumulation. That's it. Right, so that is the first principle of surveying. Now, what is the second principle of surveying? What is the second principle of surveying? The second principle of surveying is location of a point should be with respect to measurements taken from at least two well-defined points. What is the second principle? Location of a point should be with respect to measurements taken from at least two well-defined points. Okay. Please remember the definition of surveying. Okay. Like it is the what did I say the definition is? Art and science of expressing right relative positions. Okay. Relative position. Now, what do you mean by relative position? With respect to fixed reference point. When we express position, that is relative. I told you our uncle, auntie, and all. Right. They are examples of relatives. Okay. Why they are relatives? Because they are coming with respect to our fixed mother and father. Right, so in our life we have fixed mother and father for reference. With respect to them, we get relatives. But in survey, when you go to the field, you don't have any mother and father in the field. What do you have? You have something known as well-defined points. You have something known as well-defined points. So what do you mean by this well-defined points? See, well-defined point means very simply I can say like this. You know the position of that point on the paper. Okay. You know the position of this point on the paper or on the map, and you also know the position of the same point on the ground. So you know the position of the point on the paper, and you also know the position of the same point on the ground. You call that point as a well-defined point. You will call that point as what? A well-defined point. That's it. Okay, you know its position on the paper, you know its same position on the ground, you call it as well-defined points. Okay. Now, how many such points are required? You require minimum 2 such points. You require minimum 2 such points to do a survey. Mummy is there, Papa is there. How many are there? 2. 2 parents are there. It's like that. You know, we need to have 2 well-defined points in the field. Minimum 2 well-defined points in the field. Okay, right. So let us try and understand what are the different possible, combinations we can get. Okay. So please pay attention. Okay. So you imagine that A is a well-defined point, and you see B is another well-defined point. Right. A is a well-defined point. का मतलब क्या है? Sorry. Right. What do you mean by A is a well-defined point? What do you mean by A is a well-defined point? You know the position of A on the paper, you know the position of A on the ground. The position of B on the paper is also known, the position of the B on the ground is also known. Now tell me, if you know the position of A and B on the paper, do you know the length of the line AB? Please say yes or no. If you know the position of A and B on the paper, do you know the length of the line AB on the paper? Please say yes or no. So yes, very good. Very good, very good, very good. Yes. So please remember, if A and B are 2 well-defined points, I'll always know what is the length of the line AB between them. I need not repeat this, okay? I need not repeat this. In our third chapter, I will again ask a question based on this concept. I hope you'll be able to answer it. Okay, so if A and B are 2 well-defined points, I always know the length of the line in between them. Yes. Now, if there's a third point here, say C, how do I find the position of the point C? How do I find the position of point C? Right. You see, if I know one angle BAC and if I know the distance AC, can I get the point C? If I know the angle BAC and if I know the distance AC, can I get the point C? Yes or no? The answer is yes. What you do is, with B as reference, draw a line like this. Okay? Measure the angle and draw a line like this. That will be theta. Now, with A as center, AC as radius, cut an arc. With A as center and AC as radius, cut an arc. A as center and AC as radius, cut an arc. Right, that's it. That becomes the position of C. This is the position of C. So you see, the coordinate of C is what? Right. Radius L1, angle theta. Radius L1, angle theta. That's it. That is the first example. Now, what is the second example? The second example, same as before. This is A, this is B. Right. In the first case, we have taken. Like in the first case, we have taken one length and one angle. In the second case, what I can do? Tell me. In the second case, what I'll be able to do? I'll be able to take 2 angles. Yes or no? Right. First time, one angle, one distance. Second time, what will I do? I'll take 2 angles. Okay, so let me draw this one second. This is A. This is B. This length I already know. What are the 2 angles I know? Let me tell you that I know the angle. Say angle ABC. I know the angle BAC. So what is this? This is the angle BAC. And what is the next angle? Next angle is angle ABC. Next angle is angle ABC. So I know this angle as say theta 1. I know this angle as say theta 2. Wherever they are meeting here, there is a point C. So what is the coordinate of point C? Is theta 1 comma theta 2. Theta 1 comma theta 2. Next, third one. Okay, third one. Like again, same thing. Okay, I know the length of the line AB. Like so, this time what will I do? I use two length. So I use two length here. Alright, with AC length. I know the length AC. I know the length of BC. This length I already know. So take the radius AC, right, and draw an arc like this. With B as center, BC as the radius, I'll draw another arc. So where these two arcs will meet, that is my point C. Where these two arcs will meet, that will be my point C. Okay, so okay, so what are the parameters I know? I know the parameters as L1 and L2. So the coordinate of C is with respect to L1, comma L. Okay, now that is the third possibility. Is there any other possibility? Yes, there is one more possibility. So let me try and show that here. So second. There is one more possibility. Fourth possibility. This is point A. Okay, this is point B. I know the length of the line AB as L2. Now let us assume that this is where my point C is. What do I know is I know the perpendicular distance of the line AC from the perpendicular distance of C from the line AB as L1. That I know, right? And I know where the perpendicular is meeting the line as L2. Where the perpendicular is meeting the line as L2. Okay, right. So tell me what is the coordinate of C? Coordinate of C is L1, comma L2. It looks just like the previous case, L1, comma L2. But the added condition here is L1 is perpendicular to L2. L1 is perpendicular to L2. That is the added condition. Okay, L1 is perpendicular to L2. That's it. Now, if you look at this, what is the coordinate of C here? Please tell me. What is the coordinate of C? Coordinate of C is with respect to one radius L1, right, and one angle theta. What is this r comma theta known as? R comma theta way of plotting points is known as polar coordinate systems. Okay, so what we call it as polar coordinate system of plotting points. Polar coordinate system of plotting points. But the second one, where you see you're having a triangle ABC. If you know theta 1 and theta 2 of the triangle, and if you know theta 1 theta 2, you'll also get theta 3 also. So all the angles are known. Length of one side AB, we call it as baseline is known. So baseline is known for the triangle. All the angles are known. What do you call this method of plotting? We call it as triangulation. You can call this as triangulation. You can call it as triangulation system of plotting points. Okay. Now this particular third one is a different variety of the second. In second one, triangulation, all angles are measured. But in third one, no angles are measured, only distances are measured. Right. So this is a special type of triangulation known as trilateration. This is known as trilateration system of plotting points. Right. And this fourth one is what we call it as rectangular coordinate system. That's what we call it as rectangular coordinate system of plotting points. Okay. So if you look at this, our total station will plot points. Our total station will plot points in this particular rectangular coordinate system only of something known as latitude and departure. The principle of trilateration is used in GPS. Principle of trilateration. Okay, so whenever you are using GPS will never measure the distance between, will never measure the angle between the user and the satellite. It will never measure that angle between the user and satellite. But instead, what it will do? It will measure the distance between the user and satellite. Based on that, it will calculate your position. How do you calculate the position? By trilaterating your position. The triangulation surveying principle is adopted in geodetic surveying. Okay, as well as little bit in chain surveying also. Indirectly in chain surveying also. Right. And the third one is, and the last one, polar coordinate system, is not really used in like polar coordinate system. Even though the total station will measure the position, or find the position of a point using polar coordinate system, plotting is not done in polar coordinates. In fact, plotting will be done in rectangular coordinates because rectangular coordinate system has some advantages over the other system. Okay, so for that reason, we will go with the first coordinate, the rectangular coordinate system. Okay, so this is the second principle. Okay, it says that location of a point should be expressed with a minimum of 2 reference points. If only 2 are there, okay, we can go. But if you are having more than 2, it will be more accurate. For example, if you remember in your plane table survey, we have 2-point problem as well as 3-point problem. We have 2-point problem as well as 3-point problem. So now, who is more accurate? 2-point or 3-point? Obviously, 3-point problem is more accurate than our 2-point problem because more reference points are there for us to work with. Okay, now? Yes. Okay. Okay, so that is the principle of surveying. Okay, there are the first 2 principles of surveying. Right. So next, we need to look at the primary classification of surveying. Okay, the next topic that we need to talk is regarding the primary classification of surveying. So what are the primary classifications of surveying? Right. See, we will classify surveying basically into 2. Number 1, based on purpose. First classification is what? Based on purpose. First classification is what? Based on purpose. Second classification we will do is based on the instruments used. If I am using chain, it is chain surveying. If I am using compass, it is compass surveying. Based on purpose, these are the 16 surveys that we have. When it comes to our some textbooks now, they will do final classification. Rather than doing a general classification like this, they will divide surveying much more in a final classification. Okay. So if you look at this, land surveying conducted on land, city conducted on land, topographic survey conducted on land. Hydrographic survey is conducted on water. Astronomical survey is conducted on space. Like astronomical survey is conducted on space. So we have land, air, and water. We have land, air, and water. Therefore, we will combine these 2 into classification based on nature of field. Classification of survey based on nature of field. Classification based on what? Nature of field. Where am I working? Right. Where am I working? Okay. So based on that, these are the different classifications I have. Okay. Right. Now, next step, mine survey, geological survey, engineering survey, construction, archaeological, military, route, satellite survey. These are also combined together and classified based on object of survey. Based on object of survey. based on objective survey. Okay. So if they ask you for a final classification, this is what you do. Now this kind of discussion is important for our ESE students, not for our GATE students. GATE's point of view, this classification, this final classification, not very important for you. But what are these different surveys that are very important? Every year we get 1 or 2 questions. Like we get 1 question from this. If they ask you this year, they may not ask you last year. Maybe like that. Alternatively, they'll ask. But you can see a lot of questions coming from this, both in engineering services, in GATE, especially in state service commission examinations. You will see a lot of these questions. Okay. Right. So let us see what are the different surveys one by one. Okay. So let us start our discussion here. Like starting with first. One participant by one control survey. Like participant by control survey. See, control surveys, I say the definition. They are conducted to establish network of control points. What are control surveys? Control surveys are conducted to establish a network of control points. So what do you mean by control point? See, I told you, whenever we are doing survey, we need to find relative position. Relative positions means positions expressed with respect to reference points. Right. So these reference well-defined points on the field in surveying is what we call it as control points. So they will control the entire network of survey. Understand? So control surveys are conducted to establish control points. What are control points? Control points are well-defined points with respect to which the relative measurements are taken. Horizontal distance, horizontal angle, vertical distance. Everything will be taken from this particular control points. Right. Now, do you want this particular control points to be more accurate or less accurate? Just think about this. Do you want these control points to be more accurate or less accurate? There is no doubt. Obviously, we want them to be more accurate. Are they established by using plain surveying or geodetic surveying? Just think about that and tell me. Yes, very good. They are established by using your geodetic survey. Right. They are established based on their geodetic survey. Okay. So this survey is what we call it as our control survey. So control surveys are basically geodetic survey. Okay. Control surveys are basically geodetic survey, right? And they cover large extent of area. And during the control survey, we have identified a lot of well-defined points around the country, and we have calculated the positions of these particular points. Please remember, while establishing the position of a control point, for example, imagine this is South India like this. Okay. Right. See, our control survey in India, the first control survey or the control survey in India is known as the GTS survey, the Great Trigonometrical Survey, conducted in the Indian subcontinent by the Britishers. So Britishers did the survey in India because they wanted to build roads and railways. So they started from one point in Chennai like this. Right. Now, how do they express that position of a control point? They don't take horizontal distance, vertical distance, no, nothing like that. This is a control point. So the position of the control point is expressed with respect to the latitude passing through it, the longitude passing through it, and also with respect to the elevation with respect to mean sea level, and also with respect to the elevation of the mean sea level. Okay. So when you find the position of a control point in this fashion, I will call it as the absolute position. I'll call it as what? The absolute position. Okay. So you see, like they are geodetic surveys. They are conducted to establish network of control points. What are control points? They are well-defined points with respect to which relative positions are expressed. And the absolute positions of these points are expressed with respect to the latitudes, longitudes, and elevations with respect to the mean sea level. Okay. The first control survey in India was GTS survey by Britishers. Okay. So they have made this network for us. With respect to this network, we have control points. We take these control points as reference and we'll do our plane surveying within the country. Understand? That's it. So that is our control survey. The next survey that we have is what we call it as like land survey. Right. So what we call it as land survey. So what do you mean by this land survey? See, the simple definition is they are conducted to establish legal boundaries. Okay, land surveys are conducted to establish what? Legal boundaries. So you can imagine. So in our 90s now, just imagine the movies in the 90s, early 90s, and maybe you are not even born. Right? In my childhood, I can see these movies where you see one mother is there, okay, and the two little boys are there. They're playing together. Everybody's happy. Happy song will play in the movie. Okay. During this song, these particular boys will grow up. They will leave college. They will leave school. They go to college. And during this song also, they will finish their college, right? And by the end of the song, they will both get job at the same day, right? Everybody's fully happy. And by the end of the song, what will happen is their marriage will take place, right? On a single song, they will grow up, they'll get job, and they'll get married. Yes. After the marriage, full fighting starts. Fighting will be there. Right now, you can see the mother is sad, mother is crying. Now, sad song will come in the background. Right? Sad song will come in the background. Mother will be crying there. You can imagine one jeep coming to the house of this particular, people, and from the jeep, they will take the chain and everything out. They'll put the chain to the center of the area. Can you please tell me what is happening? Why chains are being dragged in that particular house or in that property? Why? What are they trying to do there? Can you please tell me? Anybody? What are they trying to do? Very good. They're trying to divide the land. Yes, they're trying to divide the property. So how do you divide the property? How do you divide the property? You will divide the property by using what? By doing surveying. Right? So if you want to establish legal boundaries within a particular property, you have to do your surveys. The survey is what we call it as land survey. The survey is what we call it as land survey, or it is also known as by another name cadastral survey. Also known as cadastral survey. Right? See, I know the example that I have taken is not a very great example, right? I know, right? Something we can relate to, but strictly in speaking in engineering terms, what is cadastral survey? What is an example of cadastral survey? If you go to 2013, right? Telangana and Andhra Pradesh, they were a single state. Telangana and Andhra Pradesh, up to 2013, they were a single state. But what happened in 2013? They got bifurcated into two separate states. They got divided into two separate states. It was almost 10 years back. Maybe you are little kids at that time. Okay. So in 2013, they got bifurcated into two separate states. Understand? Yes. Like how do you divide a state? By forming a legal boundary between them. Obviously. Okay. If you remember during COVID time, our Amit Shah, right? They divided Jammu and Kashmir, right, into two union territories. Ladakh, they divided. This you might remember. So, right, they have divided a state into two union territories. How do they do that? Again, by forming a legal boundary between them. Again, by forming a legal boundary between them. So this kind of survey that is conducted to establish a legal boundary is what we call it as land survey or cadastral survey. So you see this, right? Cadastral surveys are made incident to fixing property lines, calculation of land areas, or transfer of land property from one owner to the another owner. That is what we call it as the land surveys. Also, like you see, right, they are also made to fix the boundaries of municipalities and state and federal jurisdiction. Federal means what? International jurisdiction. Okay, so that is what we call it as the cadastral survey. So if I take the cadastral map of India, I can see the legal boundary between the states. If I take the cadastral map of India, I can see the legal boundaries between the different states. Similarly, if I take the cadastral map of, let us say, our Maharashtra, you can see, or even Maharashtra or even Kerala, you can take Tamil Nadu, whatever you take the cadastral map of a state, what you can see, the legal boundary between the different districts. If I take the cadastral map of countries, I can see the legal boundary between the countries. Okay, so that is what we call it as land survey, or also known as the cadastral survey. The third one is what we call it as city surveys. Third one is what we call it as city surveys. So what do you mean by city surveys? They are very simple. Please understand, they are conducted to conducted for the purpose of urban planning. What are city surveys? City surveys are conducted for the purpose of urban planning. Let us go back to the example I told you previously. In 2013, Telangana and Andhra Pradesh bifurcated into two separate states. Yes. Now, Telangana had the capital of Hyderabad. But what did Andhra Pradesh have? They did not have a capital. So they said that, okay, we will make one capital city in Amaravati. Okay. So they said that we are going to build our city, capital city in Amaravati. All the politicians went and brought a lot of land in Amaravati. But later on what happened? Nobody built the capital there. Okay. So if you want to build a city in a place like Amaravati, obviously you have to go and do your city survey. Because there is nothing there in Amaravati. It's just a very, very flat, fertile ground with a high water table. So if I want to do a particular, plan a city there, definitely I need to do our city surveys. Right? We have to do our city surveys. So what do we do in our city surveys? So if this is the area where I need to plan my, city, where do you think I'll put an airport? Will I put an airport at the center of the city? Absolutely not. If you put an airport at the center of the city, it will be having a lot of land issues, land acquisition problems in the future. What do? You take your airport on the outskirts of the city. At the same time, if I'm asking you to build a rail network, how will you take the rail network? Obviously, to the center of the city, because it requires maximum connectivity. So how should be the layout of this particular rail network? How should be the layout for this particular airport? All of this comes under our city service. Apart from this, you see the sewage systems, the road networks, everything is coming under our city service. Everything is coming under our city service. Okay, right. So if you look at Bangalore and if you look at Hyderabad, cities like Bangalore and Hyderabad, right, you can see that there is a lot of traffic conditions, and also especially in Bangalore, okay, if you go, there's a lot of traffic conditions. If you come to Hyderabad, just 5 millimeters of rainfall, what will happen? The entire manholes, like that manholes on the center of the road, they becomes what? Fountains like this. Just 5 millimeters of rainfall, that's enough. We can see manholes become fountains like this. Right? What happened here? See, this is not because of bad planning actually. Because you see, the sewage system of our Hyderabad was designed by Dr. Vishweshwar. We cannot say that he was a bad planner. That's not really true. Right? So that is not the correct way of saying things. Okay. So what happened is, like Vishweshwar, when he designed, he took the population growth rate and he added plus 50 years. That means whatever population is going to come in the next 50 years, they can also use this facility. But that expected 50-year population, we achieved in 5 years. 50 years, right? Whatever population we are supposed to have, we achieved that in 5 years. This is not Vishweshwaraya's problem. Okay, this is because of population explosion. The city developed, more jobs were created in the city, so many people started coming into the city, and the infrastructure was under a lot of strain. Same thing happened in Bangalore. In 1986, they said that okay, we are going to allow IT companies to start their infrastructure here. By that time, 1986 onwards, what happened? The boom started, and Bangalore city exploded with population. The infrastructure couldn't cope with that. That is why we get this traffic blockage. Understand? Yes. So next time when we go and do our planning, we can consider all these factors and we can make an effective design. That is what we call as city service. So you see, they are made in connection with the construction of street, water supply systems, where works, and other works. Understand? That is what we call it as what, city service. Okay, so I now go to the next survey. It's already 7:58. So I will stop the lecture for now. Okay, we lost some time in the beginning, right, due to that mic issue. So I stop here. So next step, I will take doubts. So next is this particular city survey. Yes or no? Yes. Okay. So now let us move on to our next discussion here. Okay. So the next survey that we need to discuss is what is meant by hydrographic survey. That is the next survey. What is meant by hydrographic survey? What is the meaning of hydro? Please tell me. What is the meaning of hydro? Hydro means nothing but water. Okay. Hydro means nothing but water. So these are surveys that are conducted on and around our water bodies. Okay. So you imagine that you're having a ground that looks like this. Okay. So you're having a ground that looks like this. Okay. And there is a water body here. Okay. And there is a water body here like this. Okay. You are expecting to build a bridge across this particular water body. So we have to do a survey around this particular water body to know the depth of water. So what we'll do is, like, we'll take a special kind of boat here known as a sounding boat. What is the name of the boat? The name of the boat is a sounding boat. Okay. So sounding is the process of measuring depth of water bodies. Okay. So if I'm saying that at a particular point A, I need to take sounding. What is the meaning? The meaning is I need to measure the depth of water body at the point. That is the meaning of taking soundings. Right. Now I will use a special type of instrument here known as a bathymeter. Right. I can use a special type of instrument here that is known as a bathymeter. What the bathymeter will do? Bathymeter will send some radiations like this. Right? The radiations will go, hit the ground, it will come like this, reflect and go back. So by measuring the time and by knowing the velocity of this radiation, we will be able to measure the depth of water bodies. Okay. Why do I call it as bathymeter? Because fathom is a unit of depth. Fathom is a unit of depth where 1 fathom is equal to 6 feet. Again, 1 fathom is equal to how much? 6 feet. So when I'm saying my water body is 1 fathom deep, roughly it is 1 man deep. Height of a man is roughly, if you take it as 6 feet, right? It is 1 man deep. So one person can barely survive, in that water. He not completely drown. But if I'm saying that the water body is 10 fathom deep, 10 people can vertically fit inside that. So if you jump into that water body without knowing swimming, you're khatam, right? You're dead, tata, goodbye. Okay. So it is very dangerous to jump into water bodies like this. Okay, right. Now apart from measuring the depth of water bodies, we do all kind of measurements regarding water bodies using this hydrographic survey. What is the stream velocity? What is the discharge? Right? What is the sea level calculation? Right? All of this is calculated in our hydrographic survey. So see. So marine or hydrographic survey deals with bodies of water for the purpose of navigation, water supply, harbor work for determination of body mean sea level, etc. Right. Next step, the work consists in measurement of discharge of streams, making topographic surveys of shores, banks, taking and locating soundings, depth measurements, to determine the depth of water body, observing the fluctuations of the ocean surface. All of this combinedly, we call it as hydrographic survey. Okay. Yes. In your Maharashtra PSC, if you take Maharashtra PSC examination, previously we used to have, at least till last year we used to have prelim examination. Objective examination was there on technical surveys. So it is the only PSC where we had hydrographic surveying in the syllabus. Okay. Now it is mains model examination for Maharashtra PSC. Yes. Moving on to the next survey, we have topographic surveys. Now, what do you mean by topology? What is the meaning of topology? Topology means nothing but the general ground features. Topography of a country means nothing but the general ground features of a country. Right? For example, hills, valleys, ridges, mountains, etc., etc. Okay. So if you are trying to represent these hills, valleys, mountains, ridges, all of these natural features of a country, then we are trying to do topographic surveys. Right? Now, are you familiar with the lines like this? Please try and answer this. Are you familiar with lines like this? Very, very irregularly shaped lines. Right? Some of the lines are very, very close to each other. Some of the lines are very, very far away from each other. If you look closely, you can see some values written here. For example, 100 meters, 120 meters, right? 140 meters like this. Can you tell me what these lines are known as? Very good. Please tell me what these lines are known as. These lines are what we call it as contours. Yes or no? Yes, it would be correct. These lines are what we call it as contours. Okay, that's correct. Now, my question is, not elevation lines, Tushar Deshpande. There is no line known as Tushar Deshpande. It is known as elevation lines. Okay, it is known as contour lines. There is nothing known as elevation lines. We call them as contour lines. Can you please tell me what is the feature this contour line is trying to represent? These lines are contours, but what is the group of lines representing? Anybody? Elevations are increasing towards the inside, right? Outside we have 100. I go inside 120, 140, etc., etc. So what is this feature here? Very good, Lalita. This is what we call it as a hill. So you see, right? These contour lines are representing my hills. Okay, that is a ground feature. Yes. So this is a topographical map. Contour maps are best examples for our topographical maps. So let us. This consists of horizontal and vertical location of certain points by linear and angular measurements. Okay. Why do we do this? To determine the natural features of a country such as rivers, streams, lakes, woods, etc. Right? And please remember, Survey of India publishes this particular topographical maps in scales ranging from 1:50,000 to 1:25,000 scales. Okay. So this was a previous year ESE prelims question. This was an ESE prelims question. Okay. And this is also asked in GATE examination recently. Okay. Right. It's a GATE previous year question also. Okay. Right. How questions in GATE will come, I will discuss at the end of this discussion. Right. Right. That is topographic survey. Now next step is astronomical survey. So what do you mean by astronomy? What is the meaning of astronomy? So please understand, astronomy means study of heavenly bodies. What is astronomy? The meaning is study of heavenly bodies. So heavenly bodies means our sun, star, the planets, moon, etc., etc. Okay. See, you might see your grandmother waking up early in the morning and watching television where one person will come and say, today the sun is going into this particular phase, so today you should wear blue color dress, you should go to this temple. What is that? That is astrology. That is astrology, okay? Right? That is not astronomy, that is astrology. Right? We are talking about astronomy. Astronomy means nothing but study about heavenly bodies. Okay, right. So what do you mean by astronomical survey? If you are taking any measurements with respect to this heavenly bodies, we can call that particular survey as astronomical survey. So if I take a measurement with respect to the sun, or if I take a measurement with respect to our moon, these measurements are known as our astronomical measurements. The advantage of taking these astronomical measurements is that, right, they will give us permanent values or constant values, because more or less the sun and the moon, everything is assumed to be at a constant positions, okay, from the earth, fixed positions from the earth, right? So whenever we take measurements from these fixed reference points, we can find out fixed values, fixed directions in it, okay, right? So that is what we call it as astronomical survey. So you see, this consists in observation of two heavenly bodies such as the sun or any fixed star. Okay. The astronomical survey offers a survey means for determining absolute locations. Absolute means permanent, fixed locations of any point or the absolute location direction of any line on the surface of the earth. Right. Now, there is a measurement that we take daily with respect to the position of sun. Can you please tell me? There is a measurement that we take daily with respect to the position of sun. What is that measurement? Can anybody please tell me? No, not east. Not east, sorry. The best example is time. Okay, what do you mean by 6 a.m.? What do you mean by this? The class will start at 6 a.m. The class will start when the sun is rising from the east. Okay, what do you mean by 12 noon? Sun is vertically above my head. What do you mean by 6 p.m.? Sun is on the west side. So what is time? Please understand. Time is nothing but a measurement that I take with respect to the position of the sun in the sky. With respect to the position of the sun in the sky. So please remember that. Okay, so example is time. Time is measurement taken with respect to a position of sun. With respect to position of sun in the sky. That is what we call it as our astronomical measure. Okay. In our engineering services, calculation of time is one discussion that we need to have. Extra topic for ESC students, field astronomy. Okay. Very interesting topic. We will see it separately. Yes. The next survey is what we call it as mind survey. When I say mind, what is the first thing that comes in your mind? When I say mind, what is the first thing that should come in your mind? Best example is Rocky Bhai. Right. Best example is Rocky Bhai. Rocky Bhai takes care of which mine? Rocky Bhai takes care of gold mine. Right. In Karnataka, right, Rocky Bhai is the dealer of gold mines. Yes. If you go to North India, right, if you go to North India, then we have somebody known as Faisal. Okay. Faisal takes care of gold mines. Faisal will take care of gold mines. Okay. So he is in Vasepur. He comes from Vasepur and he takes care of the gold mines and all. Okay. So these are people who deals with the different mines. What do you mean by mine survey then? The mine survey is nothing but a survey that we conduct to represent the distribution of mineral wealth. In which part of country, right, what mineral deposits we have. If you're trying to map that, the survey we are doing is what we call it as mine survey. Okay, so please read this. This is used to exploring the mineral wealth of a country. It is used for exploring the mineral wealth of a country. Okay. Yes, that is our mine survey. Next step, right? What was geological survey? Right, question number 8. What is geological survey? Right. See, geological surveys are conducted to understand the stratification of the earth. Okay, this is very important. You see, our earth is made up of different stratas like this. Okay, the first top is what we call it as topsoil. Okay, first 1 meter we have something known as topsoil. Some sand will be there, right? Next 2 meter we have something like gravel. Okay, like that we have different stratification. Why do we need to understand this stratification? Because there are some dangerous terrains in the earth known as limestone terrains. So limestone terrain means after this particular gravel, there will be large deposits of limestone. Say some 4 meter, we are having limestone. Okay, what is the problem with the limestone is, from the outside, the limestone will look very, very hard rocks, but inside this particular limestone, you will be having large cavity like this. Okay, so if you are looking from outside, it is a very strong rock, but in fact, it is containing large cavities inside. So without knowing this particular, physical phenomenon, if you try and put your foundation on this limestone, everything will collapse inward. Okay, this particular limestone terrain was identified in the 18th century in UK. Right, so they were doing excavation for a particular construction, right, and they reached this particular limestone. Initially, they thought that, okay, we have reached the hard rock stratum. We can, put our foundation upon this particular stratum. Okay. So they finished their excavation and they went back. But it kept on raining in UK for, one entire month, and they were unable to do construction there. After 1 month, when the rain stopped, when they came back to this particular site, what they found is a big cavity of 280 meter diameter. The top surface of this particular limestone got washed away. It will be dissolved by the water. That is known as, leaching. It got dissolved by the water and it was taken away by the water, and it exposed a cavity of 280 meter diameter. So without knowing this, if you build any construction on top of this, the cavity will collapse and the entire building will go down. That is the problem. Understand? So So it is very necessary to understand such an important, problematic terrains in the world. In our Middle Eastern countries, right, wherever we have deserts, we can see this particular limestone terrains. Okay. So in fact, our Burj Khalifa is also standing on top of a limestone terrain. So what kind of foundation did they take? Did they take isolated or shallow foundations? No, they have taken pipe foundations, which is penetrating this particular, limestone cavities. Understand? So that's the reason why they have gone with pipe foundations there. Right? That is our geological service. So it is used for determining the different stratas of Earth's surface. Right? And that is very, very important when it comes to understanding the stratification of the Earth. In fact, in your geotechnical engineering, in geotechnical engineering too, in fact, the first chapter that you study is soil investigation, subsoil investigation. You do boring, auger boring, rotary boring, etc., etc. You do, boring to understand the different classifications by using bore log data. Same principle is what we are going to use. Right. The next one is what we call it as engineering service. Right. What is the purpose of doing engineering service? Please remember, engineering surveys are used to collect design data from field. Okay. Engineering surveys are conducted for calculating design data for civil engineering works. For example, you imagine I want to build a dam at a particular location. So if I want to build a dam at a particular location, I need to know the stream velocity or the discharge in this particular stream. Then only I'll be able to know what will be the height of the reservoir forming on the upstream side. Based on the height of the reservoir only, I can fix what is the height of the dam. Right. So if the water level is supposed to rise up to 100-meter level, then the height of the dam should be 100 meter plus some freeboard we should be. Understand? But apart from that, there is another level known as, apart from this full reservoir level of 100 meter, we need to calculate something known as the HFL. What is HFL? High flood level. During an event of flooding, what is the level up to which the water will rise? So this we need to add the freeboard and we'll fix the height of the dam. So all these data needs to be collected beforehand in the field. So the process that you do to collect these data is what we call it as engineering service. So for any civil engineering works to start, the first survey we need to do is engineering survey. Right. So you see, this is undertaken for determination of quantities or to afford sufficient data for design of engineering works such as roads, reservoirs, or those connected with waste disposal or water supply, etc. Okay, all of this will come under our engineering surveys. Right. Now, please remember, engineering surveys consist of 3 different steps. Engineering surveys basically consist of 3 different steps in the field. What are these 3 different steps? Let us look at that one by one. Okay. So the first step in engineering survey is known as reconnaissance. It's known as reconnaissance. Reconnaissance, or I'll write like this: map study and reconnaissance. First step is what we call it as map study, studying the particular area in the map, followed by something known as reconnaissance. Followed by reconnaissance. What do you mean by this reconnaissance? See, reconnaissance means nothing but site visit. Okay. So before the actual survey is going to happen, the surveyor is expected to go and visit the site. The site visit is what we call it as reconnaissance. So during the site visit, the surveyor can identify a lot of information regarding what is the nature of the terrain. If the ground is flat, the ground is having too many details or not, is the ground is sloping, etc., etc. Why is this important to understand? Because based on this particular idea only, I can suggest what is the type of survey I can do there. For example, if the ground is very flat and it is not having too many details, too many features are not there, I can suggest to change survey. But if the ground is undulated, if the ground is sloping, right, then I have to go with leveling because level differences needs to be calculated. If the ground is flat but there are so many details present there, then change surveying is ruled out. I may have to go with compass survey. So to make this particular decision, the surveyor actually needs to be on the field and do inspection. Right, that is what we call it as reconnaissance. Once that reconnaissance is completed, the surveyor will go to this particular office and he will talk to the team. So that these are the details present in the area. Right, there is a fixed temple there, or there is a 220 kV substation there, there is a government building there, and there is a railway station around this area. So such very fixed points is identifying around the area. Now why he needs to identify these fixed points of reference? Because they will form or they will act as our control points. Okay, these are the fixed points of reference around which we can start working with our surveys. So we'll make our reference points around these areas and we'll start working from pole to pole. Right. So these reference points are all identified during our reconnaissance survey. Now when the actual surveying team comes to the field, we call them as preliminary survey. We call them as the preliminary surveys. Okay. So, preliminary surveys are the actual surveys that we conduct on the field, and all the necessary measurements will be taken. So, if you are trying to, set out the location of a road, the center line of the road is also surveyed and established during this preliminary survey. Right. Center line of the roads are also established during this particular preliminary survey. In fact, some small, shallow soil investigation is also done during this preliminary survey. Shallow for explorations will be done around 1.5 to 2 meter depth during this preliminary survey. Right. Once that survey is over, what we'll prepare maps and plans. From the maps and plans, we'll be able to calculate areas and volumes, and we are able to make the estimate of our construction. What will be the cost of our construction? It may be for a house, it may be for a dam, it may be for a thermal power plant. Whatever is the cost of construction, we'll be able to estimate it. Understand? So once that particular estimate is okay with our client, like the finance, everything is okay, right? Then what we'll do, we will try and put this particular plan onto the field. That's the last job of the surveyor. What is that? Setting out. Okay. So the last job of the surveyor is right set out. Location surveys or setting up. Okay. These are the 3 works involved in our engineering surveys. Go do site visit, go do actual surveys, right? Make the design and put that particular plan of the design onto the field. So these are the different works involved in our engineering surveys. That's it. Right. Now, once the engineering surveying is completed, what happens? We set out the position of the different columns on the field. The moment the setting out work is completed, who will come to the field? The JCB will come to the field and they will start digging foundation for starting the construction. Okay. Now, when you are doing this particular construction, we may have to take a lot of measurements to proceed to take the construction forward. Right. our masons and our the builders, they will be having tapes and all with them, and by using these maps to guide the construction forward, in the construction site they will take a lot of measurements. These measurements are what we will categorize as construction surveys. Okay, so construction surveys are to stake out. Stake out means nothing but set out. Okay, set out reference points and markers that will guide the construction of any new structures as roads, buildings, etc. Right, forward. To carry forward the process of construction, whatever markers we find out in the field, whatever small measurements we take in the field, all of that will be categorized under our construction surveys. Okay, that's it. Now the next survey is what we call it as our archaeological survey. Next survey is what we call it as archaeological survey. What is the purpose of archaeological surveys? They are used for unearthing relics of antiquity. They are used for unearthing relics of antiquity. What do you mean by antiquity? What is the meaning of antiquity? Some of you know antiquity as something that you drink. That is not the antiquity here. Antique objects, or antiquity refers to something that is very very old. Antique objects means something that is very very old. Relic means it is a very very precious material or very very costly material or something that we cannot put a price tag. We cannot put a price tag on this. That is what we call it as a relic. So it is something that representing our ancient past, and it is not something that is you can put a price tag. It is an invaluable material. Okay, that is what we call it as relic of antiquity. An object that represents our ancient past, which is invaluable for our human history. Okay, right. What the archaeological department will do, they will try and unearth it. So they will find a particular site very interesting. They will isolate the site and they will keep on digging right until they come up with something like this. So if you have seen the movie Mummy, there's one Bollywood movie known as Mummy, where they will go to Egypt, right? They go inside the pyramids. So this is the pyramid. There are a group of archaeologists like this. Okay, they will be having their caps and all like this. They will go inside this particular pyramid, dig like this. After digging for 1 or 2 days, they will find a box where Mummy is sleeping. Okay, inside this box, Mummy is there, but together with Mummy, right, there are so many valuable things like gold and all. Okay, right. So they will open the box, take all these things, they will go out and they will try and sell it in the market, black market. This will be very 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 costly. Correct now? Yes. Now what happens? Mummy wakes up. Okay, this is Mummy. Mummy wakes up. Mummy walks like this. Okay, Mummy is very angry. Mummy go outside, kill everybody, take everything, and come back to sleep. Understand? Right. So this is the best example of your archaeological survey. Okay. Same story, 3-4 parts they have. Okay. So that is the best example of our archaeological surveys. Right. You can see this in the movies. The next survey is what we call it as our military surveys. Yeah. Next survey is military survey. As the name suggests, who will conduct this survey? As the name suggests, right? Who will conduct this particular survey? Who is this? I'm blocking this anonymous people. You keep on putting the same message again and again. If I'm not answering means I'm ignoring. Don't behave like this. Okay. You copy paste messages. I'm going to dismiss you. Okay. Don't put messages like this. Why I did not take class yesterday? I told you right at the beginning of the class. These anonymous people, they are all headache only. Keep on disturbing. They will not even put their name and keep on putting unnecessary questions like this. Why I did not take class? I told you right at the beginning of the class. Either you come at 6 o'clock or you don't ask questions at the middle of the class. Okay. And don't keep on copy pasting it. No, have some manners. Okay. So I block the anonymous attendees. Every time these anonymous attendees will be headaches like this. But they will not reveal their name. Simply put some base questions like this. Okay. Right. So next we talk about military service. So what do you mean by military service? So military survey, as the name suggests, will be conducted by our military. Okay. So don't think that our Jawans with the AK-47 they will go and do this particular service. No. We need to write examinations like engineering services or SSCJ or even railway services we need to write and get into railway department. Sorry, not railway services, military services we need to write and we need to get into the military department. So we will be in the military engineering services. So writing IES, you will be in the military engineering service. So you as a civil engineer, you need to do surveying in the field, right? So that you can identify strategic points of importance. You can identify strategic points of importance. So you see, this is conducted for determining points of strategic importance. That is why we will do military service, right? That's it. Okay. So if you've seen this movie Sher Shah, you can see, right, our Indian soldiers are trying to capture one point in the on top of a hill. Why? Why do we need to capture that point in the hill? Because that single point in the hill can control the entire valley. That single point in the hill will be able to control the entire valley. So if you want to move our military equipments, our military people around that particular valley, if Pakistan is occupying that particular bunker, we will not be able to do that because they can easily attack us. So to prevent this from happening, we need to capture the strategically important points in the mountain range sites. Right. So how do I identify where these particular points are? These can be identified by using our contour maps. You see, one of the most important uses of contour map is to identify points of maximum intervisibility. Which points will give us maximum intervisibility at a particular location. This can be identified by using our contour maps. Right. So have you seen this Hrithik Roshan movie Lakshya? In that Hrithik Roshan movie Lakshya, this is what happens. Okay. First half is wasted. Forget about the first half. In the second half, this is what happens roughly. Okay. So there's a feature like this. Okay. It's a cliff like this, vertical cliff like this. There is one bunker there. There is one bunker here, and Pakistan is occupying that particular bunker. Right. This is a point of strategic importance. Our Indian Jawans are trying to come and capture this, but as Pakistan is at a higher ground, they are having advantage. They can simply shoot like this. So we are blocked at this particular location. Right. So just then who will come? Amitabh Bachchan will come, and he will come with the contour map. They will identify that this is a vertical cliff. This is a vertical cliff, and Pakistan is thinking that no way they can attack from this vertical. So what happens is Hrithik Roshan and friends will take a helicopter right at night. They will come right and they will land here like this. Right. From this helicopter, right, what they will do? They will jump like this. Okay, and they will land at this particular location. So this is Hrithik Roshan coming down in a parachute like this. So he will come like this. Now Hrithik Roshan and friends, they will slowly climb up like this. Slowly climb up like this. So when they reach this particular edge, they will ask Amitabh Bachchan to increase the shelling here. So they will keep on putting lot of shells here like this. Okay, so Pakistan is fully concentrated here. So now they will attack from behind and they will eliminate this. Okay, so how did they identify that? You can launch an attack from this particular site. That is by identifying this geological feature known as the vertical cliff by using contour maps. Okay, so that particular discussion is the best example of how I write contour maps and the general ground features of the country will help us have an advantage over our enemies. Understand? So this is all part of our military service. Okay, right. Now next survey that we have is what we call it as construction survey. Yes. The next survey that we need to discuss is what we call it as route survey. Okay. Now please tell me, is transportation over for you? Transportation over for you? Please yes or no? Yes. Okay. So transportation is over for you. So in your transportation engineering, you have in the first chapter you have studied something known as the concept of maximum utility. Okay, you have studied the concept of maximum utility. So there is a route P like QR connecting villages with a 100 people population, like connecting another village with the 500 population, connecting third village with the 300 population, like having industrial products and agricultural products like this. Now, which is the best possible route, right? So that maximum service, maximum utility is obtained. I hope you remember this. Okay, what is the amount of industrial product carried along this particular route? What is the amount of agricultural product carried? What is the number of villages with population and with good population and connecting? This is all done by taking one arithmetic, weighted arithmetic mean. That will give me the best possible route, right, where we can get maximum utility. I hope you remember. So the question here is, how do I know that this road is connecting this many villages? How do I know this much agricultural product, this much industrial product is being carried through this particular road? How do I know that? It is done by using our route survey. So if you look at the route P, what I'll do is I'll form a surveying team and I'll ask the surveying team to go along this route. I'll send another surveying team to go along the route Q, and I'll take another surveying team and I'll ask him to go along the route R. Once all these three route surveys are completed, I will take these informations. Now I can do the concept of maximum utility analysis and decide which is the best route for maximum utility. Right? So this information about the villages and industrial and agricultural products is collected by doing survey. That kind of survey is what we can call it as route survey. That kind of survey is what we call it as route survey. Okay. So you see, like surveys necessary for the location and construction of lines of transportation or communication that continue across country for some reasons. Okay. So such as highways, railroads, open conduit system, like open channel flow canals, pipelines for carrying oil and power and the telecom lines for taking gas lines, etc. All of this comes under our road service. Right? That's it. Okay. Now the next survey that we have is what we call as satellite survey. As the name suggests, satellite surveys are nothing but surveys conducted with respect to satellites. So if I'm using satellites to find my positions on the surface of the earth, that is what we can call it as satellite survey. The best example is nothing but what? It's nothing but your GPS. Okay. The best example is nothing but your GPS service. Okay. So we will have a user device in my hand and we'll try and connect with the different satellites in the sky, and that will give us an idea about where we are standing, how we can navigate. Right. That's it. The next survey, what we have is known as gravity survey. Tell me, what is the G value is equal to? What is the value of gravity is equal to? The value of gravity is 9.81 meter per second square. Is this value constant? The answer is no. This value is not constant, because if you look at the Earth's surface here, the Earth is having, right, northern hemisphere completed with the land, and southern hemisphere, completed with what? Southern hemisphere mostly filled with the water bodies. Okay, so we have land and water bodies. Right, we have land and water bodies. Okay, and the land is having one density, water is having, southern hemisphere filled with the water bodies. Okay, this is what? Okay, this is land masses. Okay, like so. Land is having one density and our land is having other densities. So due to this varying density distributions, gravity value will be different at different locations. If you want to find the exact G value at a place, the survey you do is what we call it as gravity survey. Right? That's it. Now the last survey we need to discuss is our general purpose survey. See, general purpose surveys are conducted to obtain qualitative and quantitative data. It is conducted to obtain what? Qualitative and quantitative data. For example, you imagine that you want to improve the signal timing of a junction. Right? So you can think about the busiest junction that you can know near your house, and imagine that you need to improve the signal timings. Like since you study transportation, you might know this very clearly. Okay. So what you need to do is you need to first of all go to that particular signal or junction, and you need to do your traffic volume studies. Okay. So you need to take up a position here like this in this particular junction. So this is a crossing like this. Okay. And you need to take your traffic volume studies. So you need to stand there and you need to count the number of LCVs passing. Right. And what do you mean by LCV? Light commercial vehicle. HCVs, heavy commercial vehicles. Okay. Right. So you need to count them for 1 hour. If you don't want to do that, if you don't want to stand there and count, what you can do is you can take your mobile phone, put your mobile phone on record, video recording, right, and go home, right, and sleep for 1 hour and come back. Right. So after 1 hour, you come back to the site. If the mobile phone is still there, take the mobile phone, look at the video, count the number of LCVs passing, count the number of HCVs passing. Okay. Right. Now you can do your analysis. You have your traffic volume. You can have your analysis. You can improve the signal timing so that the traffic congestion at this point is reduced. So if the traffic congestion is at the point is reduced, what happens? My road users will feel more comfortable. Okay, and they will prefer to use this road. So if there is two routes to reach one location, one route is having high traffic, the other route is having less traffic. Which one will you select? Obviously, we will select the one which is having lesser traffic. Right. So that is the qualitative aspect of a less congested route. If it is less congested, the quality of our transport will be better. Okay. To improve that particular quality of our transportation, we have counted the number of vehicles passing through that particular area. The count of number of vehicles is what we call it as a quantitative aspect. Understand? So qualitative and quantitative aspect both are included in our general purpose service. Example is traffic volume studies. Example is traffic volume studies. That's it. So these are the different surveys that we have based on our purpose. Okay. Now, you can definitely get a question from this area in your gate examination. Generally they ask. And obviously in your engineering services also you get, as well as your state service commission examinations, and PSUs also ask questions from this area. Okay. How do they ask a question? See, nobody is going to ask you to write down all these 16 surveys. No, absolutely not. What they'll do is, they'll give you one definition. They'll just give you one definition. You need to read the definition and you need to identify what is that survey from the 4 options. For example, I'll ask you one question, please try and answer this. Survey conducted to represent the general ground features of the country are option A, geological survey, option B, mine survey, option C, topographic survey, option D, let me say something like say hydrographic survey. What will be the answer for that question? Survey conducted to represent the general ground features. Yeah, it is nothing but our, no, Praveen, it is not geological survey, it is topographic survey. Not geological survey. Very good, Aditya. Very good, Ananya. It does nothing but topographic surveys. Okay, then we also done. Yeah. Geological surveys are used to represent stratification. I know you will have a confusion. That's why I put both these options in the question. Okay. Geological survey will talk about the stratification of the earth that you cannot see. You have to take borelo data to see it. But topographical features are what we can see. That is represented by topographical surveys. That's it. So be clear. So to answer questions like this, what you need to do is you need to read this particular 16 survey at least once. You need to read them at least once. That's it. Or maybe even twice. Be in a position to identify the definitions. So read it 2-3 times very clearly. That will be more than sufficient. Okay. Right. So you should not miss out marks from this area. Okay. This is very easy to score. So don't miss out marks from this particular area. So that was our classification based on the purpose. The next classification is based on the instrument that I use. Okay. Please try and tell me what is the first basic measurement. In survey we have 4 basic measurements. Tell me the first basic measurement. What is the first basic measurement? Starting by horizontal distance. No, Sharavan. Right? No, Sharavan. It is horizontal distance. No, Ananya. It is horizontal distance. Okay. First basic measurement is horizontal distance. To get that horizontal distance, what is the instrument I use? The instrument I use is a chain. Okay. So the survey is known as your chain survey. Okay. Surveying is known as your chain survey. The second basic measurement is horizontal angle, which is measured by using a compass. Therefore, the survey is known as compass survey. The third survey is a plane table survey, which is the graphical survey. It is the only graphical method of surveying where I get the horizontal distance and horizontal angles. Okay. The third basic measurement is vertical distance, that is calculated by using level and leveling stuff. We call it as leveling. The fourth basic measurement in surveying is what we call it as vertical angle, which is measured by using theodolite. We call it as theodolite survey, or we can even call it as our trigonometric level. Okay. Once these 4 basic measurements are completed, we can have our tachymetric survey. What happens in tachymetric surveying is you are going to get all 4 basic measurements together. Right. So a tachymeter is nothing but a modified version of our theodolite. Please remember, theodolite can give you vertical angle as well as horizontal angle. Now, if you modify the theodolite, you can calculate distance also by using a formula K into S plus C. K into S plus C. You can calculate your horizontal distance. So tell me, if you know the horizontal distance, if you know the vertical angle, can you calculate vertical distance? Yes, we can calculate vertical distance by using a formula V is equal to D times tan theta. By using a formula V is equal to D times tan theta. That's it. I can calculate my vertical distance like this. Yes. So I have the vertical angle, I have the horizontal distance, I have the vertical distance, and I also know the horizontal angle. So all 4 basic measurements are given by our tachymeter. In fact, the total station was inspired from the tachymeter. Total station is a digital equipment, it's very accurate, but tachymeter is an optical instrument, so accuracy is a little bit less. That's the only difference. Right? After that, we have photogrammetric survey, right? And we have followed by total station and the ADMI surveys. In fact, this is the syllabus of survey. This is the syllabus of survey. Okay. So after the first chapter, this is second chapter, third chapter, fourth chapter, 5, 6, etc., etc. This is the syllabus of our survey. Okay. Right. So the point I'm trying to make is we will study only the surveying, classification of surveying based on the instruments used. Right. Based on the purpose used, we already discussed. We are not going to see that again. Right. That's it. So this is our primary classification of survey. Right. Now let us discuss about maps and plans. What was the first objective of surveying? Tell me, what was the first primary classification of survey? Right. Now let us discuss about maps and plans. What was the first objective of surveying? Tell me, what was the first objective of surveying? The first objective of surveying was preparation of maps and plans. Okay. So what do you mean by maps and what do you mean by plans? This is what we need to identify. Please remember, maps and plans are nothing but the representation of the Earth's surface on a horizontal plane. I hope you agree. What are maps and plans? Maps and plans are nothing but the representation of the Earth's surface on a horizontal plane. Okay. That is what we call it as maps and plans. But the question is, when do I call this representation a map? When do I call this representation as a plan? So both the map and the plan, they are both representing the Earth's surface only on a horizontal plane. No doubt. Map also represents the ground on a horizontal plane. Plan also represents the ground on a horizontal plane. But the question is, when do I call this representation a map and when do I call it as a plan? One basic difference you can see is maps will represent larger extent of area, while plans will represent smaller extent of area. So larger extent and the smaller extent. Right now, you don't go to a shop and ask for plan of India. You don't ask for plan of India. You ask for map of India. You don't go to an engineer and ask for the map of a building. No, you ask for a. So after the first chapter, this is second chapter, third chapter, fourth chapter, 5, 6, etc., etc. This is the syllabus of our survey. Okay, right. So the point I'm trying to make is we will study only the surveying, classification of surveying based on the instruments used. Right. Based on the purpose used, we already discussed. We are not going to see that again. Right. That's it. So this is our primary classification of surveying. Right. Now let us discuss about maps and plans. What was the first objective of surveying? Tell me, what was the first objective of surveying? The first objective of surveying was preparation of maps and plans. Okay. So what do you mean by maps and what do you mean by plans? This is what we need to identify. Please remember, maps and plans are nothing but the representation of the Earth's surface on a horizontal plane. I hope you agree. What are maps and plans? Maps and plans are nothing but the representation of the Earth's surface on a horizontal plane. Right? That is what we call it as maps and plans. But the question is, when do I call this representation a map? When do I call this representation as a plan? So both the map and the plan, they are both representing the Earth's surface only on a horizontal plane. No doubt. Map also represents the ground on a horizontal plane. Plan also represents the ground on a horizontal plane. But the question is, when do I call this representation a map and when do I call it as a plan? One basic difference you can see is maps will represent larger extent of area, while plans will represent smaller extent of area. So larger extent and the smaller extent. Correct now. You don't go to a shop and ask for plan of India. You don't ask for plan of India. You ask for map of India. You don't go to an engineer and ask for the map of a building. No, you ask for a plan of the building. You ask for plan of the building. Understand? That's it. Okay. So this is one basic difference that you can see. Now Please understand, whether you take a map or whether you take a plan, in both of them, what will be given? A scale will be given. There is no doubt in that. Whether you can see. A map or a plan, definitely what will be given there? A scale will be given. So the question is, what do you mean by the scale of drawing? The question is, what do you mean by the scale of a map or a scale of a plan? You see, if I write like this, 1 centimeter is equal to 10 meter, is this a scale? Yes or no? Absolutely yes, no doubt. 1 centimeter equal to 10 meter is nothing but scale. What is this scale trying to tell you? This scale tries to tell you that every 1 centimeter on your paper is going to represent what? 10 meters on the ground. Every 1 centimeter on your paper is going to represent 10 meters on the ground. So basically it tells you the relationship between the distance on the paper to the corresponding distance on the ground. Understand? It tries to tell you the relationship between a unit distance on the paper to the corresponding distance we are having on the ground. That's it. So that is the meaning of scale. A relationship between map or plan distance, which is nothing but a paper distance, I will call it, okay, to the corresponding distance on the ground. So when I write the scale is 1 centimeter equal to 10 meter, every centimeter on the paper is going to represent what? 10 meters on the ground. Now, depending upon how much of this ground distance I am representing, am I representing 10 meters? Am I representing 100 meters? Right, etc. Depending upon how much ground distance I represent, we have the following different types of scale. First one is what we call it as large scale. Okay. First one is what we call it as large scale. So in large scale, what happens is 1 centimeter on the paper will represent a distance up to 10 meters on the ground. It will only represent to a maximum of 10 meters on the ground. Second one is what we call it as a medium scale. Second one is what we call it as a medium scale. So what happens is every 1 centimeter on the paper will represent 10 to 100 meters on the ground. Every 1 centimeter will represent 10 to 100 meters on the ground. And third one is what we call it as a small scale. Third one is what we call it as a small scale, right, where every 1 centimeter on the paper will represent a distance more than 100 meters, more than 100 meters on the ground. That's it. So depending upon how much ground distance I represent, these are the scales I have: large, medium and small scale. Now, please tell me, out of these three, who is representing the largest ground distance? Batao. Among these three, who is representing the largest ground distance? Please tell me. Tell me, what is this work from whole to part? What did you say work from whole to part? I don't know. Yes. Yes. Very good. Very good. Very good. So who is representing the largest ground distance? Small scale is representing the largest ground distance. So we'll get one very, very important, understanding. What is that? Small scales represent larger ground distance. Large scale represent smaller ground distance. Correct now? Yes. Small scales will represent large ground distance. Large scale will represent small ground distance. So now comes the main difference between maps and plans. Can you tell me, to prepare a map, what kind of scale I should use? Tell me, maps are prepared with what scale? Large scale or small scale? Batao. Maps are prepared with large scale or small scale? Please tell me. Yes, very good. Maps are prepared with a small scale. And plans are prepared with a large scale. Okay. So next time anybody asks you what is the difference between maps and plans, rather than saying the area, you should say that scale. You should say that the plans are prepared with a large scale and maps are prepared with a small scale because of the distances they are supposed to represent. Okay. So let me write down that 2 points here. So note. So plans are drawn with a small scale. Okay, so please remember that. Right. So that is the difference between maps and plans. Please try and solve this problem. Please try and solve this problem. I'll give you 2 minutes. Please solve it. Okay. Right? But both of the answers are in kilometers per hour. Right? Please read the question. They are asking you the answer in the new map. They are asking you for the answer in the new map. Okay. So you need to say the answer in terms of paper unit only. Kilometer is never in paper unit. Kilometer distance you always get in ground only. Okay. Paper unit will be centimeters per millimeters per etc. Let us try and solve this. So they are saying that in a plan, right, on a plan, initially we are having a plan. On this plan, we are having a ground which is having a dimension of how much? 10 centimeter by 30 centimeter. It's having a dimension of how much? 10 centimeter by 30 centimeters. So what I will do is, I will first convert this particular dimension from paper unit to ground unit. I will convert this, dimension from paper unit to ground unit. So if I want to do this conversion here, what should be the scale I should use? Right, the scale of the plan is 1 centimeter equal to 100 meter. So the conversion should be used, by using this scale. What is the meaning of this scale? Every 1 centimeter on the paper will represent 10 meters on the ground. Okay, sorry, 100 meters on the ground. So please tell me what will be the 10 centimeter distance will represent? 10 centimeter will be equal to 10 into 100 meters on the ground. That is nothing but 1000 meters. Okay, 30 centimeter will be 30 into 100 meters. That is nothing but 3000 meters on the ground. Now, this ground is what we are going to do. This ground is what we are going to represent in a new map. In a new map, right? And how is this ground going to be represented? This ground is going to be represented by using a scale of 1 centimeter equal to 1 kilometer. Which means every kilometer length on the ground will be representing 1 centimeter on the paper. Now tell me, 1000 meter means how many kilometer? 1 kilometer. 3000 meter means how many kilometer? 3 kilometer. So if every 1 kilometer is equal to 1 centimeter, right? Our first dimension will be what? 1 kilometer will be represented as 1 centimeter, right? And 3 kilometer will be represented as 3 centimeter. Now tell me, what is the area of this plot in the new map? 1 centimeter into 3 centimeter. Our answer is 3 centimeter square. Our answer will be what? 3 centimeter square. Our answer will be 3 centimeter square. So this is how we will, find our answer. Okay. Yes. So, I'm a little bit disappointed that nobody got this particular answer correct. So the answer should be 3 centimeters square. Kunal is asking, sir, is the content enough for ESC, GATE and PSU? The answer for that question I already given in the first class itself. Okay. First 5 minutes only if you watch now, you will know the answer for that. The answer is yes. For GATE, PSU and ESC, this is sufficient. But for ESC, you need to read extra. I don't have to say this again and again and again. Please understand, you have to do some 10% of work from your side extra for ESC point of view. Right. Anyway, you will get 90% of the content from our notes only. 95% you will get, but you need to add some 10% extra for every subject. Okay. Please remember. Yes. So I hope this particular question is clear for you. This is how we can find our answer. Very easy way of finding the answer. Graphically, I have used our solution there. Now, please remember, right? How did I represent my scale? How did I represent my scale? I represented, or I wrote my scale as, you see, 1 centimeter equal to some meters. For example, I say 1 centimeter equal to 2 meters. So here centimeter meter, what is this? This is the distance we are talking. So this is what we call it as scale, and this is the distance measure. We are talking about distance measure only. Always remember, scale is always expressed in terms of paper distance and ground distance only. I can extrapolate that. If every 1 centimeter represent 2 meters, every 1 centimeter square will represent how much on the ground? 4 meters square on the ground. This is what we call it as representation of scale in area terms, in area measure, right? And I can again say that every 1 centimeter cube will represent what? 8 meter cube. Okay. What is this? This is volume measure. This is volume measure. Okay, now, right? So this is how these particular parameters. But please remember, our scale is only like what distance. So this is what I call it as scale. I'll not call this as scale. I'll not this as scale. These are useful for problem solving. Okay, these are useful for numericals. Right? For numericals, we can use this. It is easy for us. But please remember, our scale is always the relation in terms of scale, not the relation in terms of area, not the relation in terms of volume. But that understanding is useful for solving problems. That is the only idea. Okay. So these are some standard scales that we have. Okay. So for building site, we have scales. Right. For town planning scales, road surveys, and mine surveys, we have scale. Forest map, geographical maps, we have scale files. Right. Please go through this for ESC. Right. As ESC students, I will suggest you go for this. GATE students, ignore. GATE students, just ignore. PSU students and PSC students can also look for it. Right. PSC and PSU students can also go through this. Try and actually memorize at least 1 or 2 of these particular values. Or some 2-3 examples you please remember. GATE students ignore. Other students just you need to look through. Okay now. Right. If you're writing examinations other than GATE, you need to just go through this because they tend to ask you some memory-based data in such examinations. GATE will not ask you any memory-based questions, right? So study these tabulations, these standard values mostly for your examinations other than GATE. Okay, right. Next, we'll talk about the representation of scale. The next discussion is what we call it as the representation of scale. What are the different ways in which I can represent the scale of a drawing? The first representation is what we call it as engineer scale. Okay, first representation is what we call it as engineer scale. So let me show you how engineer scale is represented. So engineer scale will be represented something like this. So 1 centimeter is equal to 2 meters. What is that? Engineer scale representation. So here we are equating paper distance and ground distance. So whenever we are able to write the scale, the relation between paper distance and ground distance by using an equation like this, such a representation is what we call it as engineer scale. Such a representation is what we call it as engineer scale. Another example is I can write like this: 1 centimeter is equal to 50 meters. That is also engineer scale. 1 millimeter is equal to 3 meters. This is also engineer scale. 1 inch on the paper is equal to 6 feet. That is also engineer scale. Okay. So this way of writing the scale is what we call it as engineer scale representation. If you remember our numerical here, what is the kind of representation I used here? What is this? This is also nothing but our engineer scale representation only. That's it. Okay, right. This is what we call it as the first representation of our scale, that is engineer scale. Right, not very important for us. But the next one is slightly important for us. Just give me a second. 1 second. Just give me. Okay. So the next representation that we have is what we call it as, after engineer scale, the second one that we have is what we call it as representative fraction, which I will simply write it as RF. So what is meant by this representative fraction? Please read this statement. It is nothing but the ratio between a unit map or plan distance to the corresponding ground distance, right, expressed in the same unit. So as the name suggests, representative fraction is nothing but a fraction. It's nothing but a ratio, numerator by denominator. When will I call a fraction as a ratio? When will I call a fraction as a ratio? I will call the fraction as a ratio only if the numerator and the denominator are expressed in the same unit. Generally, we write the scale as some 1 centimeter is equal to some x meters, x kilometers, etc. We write. So paper distance is having one unit, ground distance is having another unit. But here we will try and make them into same unit so that we can express them as a ratio. That's it. In the general format, the representative fraction will be written as either 1 in n, or the same thing can be written as 1:n. Right, that is the general idea of representing the fractions. So let us take some small examples here and try and represent our representative fractions. Okay. So I'll take an example of a large scale. So let us take an example of a large scale. So I hope you remember what is large scale. 1 centimeter on a paper will represent a distance up to how much? Up to something like 10 meters. So I'll take an example of large scale. Say 1 centimeter is equal to 5 meters. This is a large scale. So if I want to represent this into a representative fraction, what I need to do? क्या करना है मुझे? Paper distance and ground distance, I need to express them both in the same unit. Right. So will I convert centimeter to meter or meter to centimeter? Obviously, meter to centimeter is the easier option. What I'll do is I'll convert 5 meters into centimeters. I'll multiply that with 100. So now what happens? Right, this centimeter is equal to 500 centimeter. Now I can cancel off this centimeter. What is going to be my representative fraction? My representative fraction will be 1:5. That's it. Right. Now similarly, one more example I take, that is small scale. I'll take the example of a small scale. I hope you remember what is small scale. 1 centimeter on the paper will represent a distance more than 100 meters. Let me say 1 centimeter to 500 meters. Is this small scale? Yes. Large ground distance, there is nothing. Let us convert this into RF. So 1 centimeter is equal to 500 meters into 100 centimeters. Centimeter will cancel. Now what is going to be my representative fraction? It's going to be 1 followed by 500 followed by 1. So 1 upon 50,000. Okay. So these are the two scales I got. I will call this as scale number 1, RF number 1, and I will call this as RF number 2. So please look at this RF number 1 and RF number 2. And can you please tell me which RF is smaller? Which fraction is smaller? First fraction is small fraction or second fraction is small fraction? Please tell me. Who is the smaller fraction here? Who is the smaller fraction here? Very good. Second one is the smaller fraction. Second one is the smaller fraction, right? So therefore, we will go with this particular scale as small scale. Correct now? Second fraction is smaller fraction. If the fraction is small, I'll call the scale as small scale. Okay. If the fraction is small, I'll call the scale as small scale. That's it. Okay, right. That is what we call it as small scale. The second fraction is larger fraction, therefore I call it as a large scale. Now, how did you know that the second fraction is smaller fraction? Second fraction is smaller because you look at the denominator of the second one, it is 50,000. Look at the denominator of the first one, that is 500. So the second fraction is having a higher denominator, larger denominator. So please remember, whenever the denominator of the RF is large, the scale is small. Okay, so I'll write like this and note, right? Larger the denominator of RF, smaller is the scale, and vice versa. Smaller is the scale and vice versa. Larger the denominator of the RF, smaller is the scale of the drawing. Okay, na? Yes. Now, why am I discussing like this? Because in your PSU levels and in your SSC and all those kind of examination, they will ask you questions like this. Identify the smallest scale. So who will be the smallest scale? The smallest scale will be the one which is having obviously the largest denominator. The smallest scale is the one which is having the largest denominator. So what you can do is, you can convert everything into RF and see who is having the smallest scale here. Okay. So how can I change this engineer scale into RF? 1 centimeter is equal to 5 meters is nothing but 5 meter multiplied with 100, 500. This is already given as 1 upon 50. How can I write this? 1 centimeter equal to 500 meters. 500 multiplied with 100, so 2 more zeros will come. And what is this? This is already given as 1 in 5,000. So who is having the largest denominator? The largest denominator is C. So this is the smallest scale. This is the smallest scale, right? Now, if I ask you who is the largest scale here, can you tell me who is the largest scale here? Yes, largest will be B. Yes, very good. Yeah. So this will be the largest scale. Okay. So I hope you get the idea. Okay. Now for GATE and all, you not expect questions like this. For your PSCs and you may PSCs and PSUs, you may get questions like this. Okay. Right. Now this is a previous year ESE question. Please try and solve this. This is a previous year ESE question. Please try it. Okay. Tell me the answer. No, this is not scale. This is not scale, right? Because it is different values here. So an area of 16 kilometers square is represented as 4 centimeters square. This is previous year ESC question, okay? Right. So what you are saying is 4 centimeters square on paper is equal to 16 kilometers square. Please tell me, is this scale? Yes or no? No, this is not scale. This is not scale, right? Because it is not talking in distance. It is talking in area. So is this area measure? Yes or no? The answer is again no. It's not area measure. If you want to make this into area measure, you should write it this format. 1 centimeter square is equal to 16 by 4. What is 16 by 4? 16 by 4 is nothing but 4 kilometers square. Right. So if every 1 centimeter square is representing 16 kilometers square, sorry, every 4 centimeter square is representing 16 kilometers square, 1 centimeter square will represent 4 kilometers square. This is what I can call it as area measure. This is what I can call it as scale in area measure. But this is not scale. This is not scale. If you want scale, you should express them in distance measure. Right. So 1 centimeter square represent 4 kilometers square means 1 centimeter will represent how much? 2 kilometer. You need to take square root on both sides. This is what we call it as scale. This is what we call it as scale in distance measure. Okay. So remember, I clearly told you, right? Scale is always expressed in distance only, not in area, not in volume. Area and volumes will help us. Area measure and volume measure will help us in the numericals. Please try to understand, right? It will not help us in our scale determination. Now they are asking you to represent this in an RF. So every 1 centimeter will represent 2 kilometers. To convert kilometers into meters, I should multiply it with 1000. To convert meters into centimeters, I should multiply that with 100 and centimeters. So that centimeter will cancel. I'll get the scale as 2 followed by 1, 2, 3, 4, 5. That is our RF. That is our RF. That's it. Okay. So this is how you find the RF of the RF. Right. So did anybody get it correct? No. Okay. So I hope Ananya got it correct. Yes, Ananya. Okay. I hope you got it correct. Okay. Very good. Yes. So that is the second representation of scale, what we call it as a representative fraction, and we saw a numerical on that as well. Right. Next, we'll talk about our third representation of scale. We'll talk about the third representation of scale, that is known as the graphical scale. Okay, so this is our graphical scale. Now, graphical scale is slightly, different, okay, and rather more important than the previous two scales. Okay. So, what do you mean by graphical scale? Okay. What do you mean by the third one? What is meant by a graphical scale? What is meant by graphical scale? Okay. See, graphical scale is, explained something like this. Like the definition goes something like this. It is nothing but a line drawn on the map or a plan. Like you read the definition. It is nothing but a line drawn on the map or a plan and it representing a corresponding ground distance. Line drawn on the map or a plan representing a corresponding ground distance. This is what we call it as the graphical scale. The first two scales we can call them as numerical scales. First two scales we can call it as numerical scales, right? But the third one is a graphical scale. Right? What is the meaning of this? So what they will do is they will simply if you imagine that this is a map here, this is a map here. What they will simply do is they will say that right this much distance on the paper right will represent what some distance on the ground. So they will simply draw a line like this and they say if this is equal to 0 meters, this is equal to 100 meters. What is the meaning of this statement? See, the meaning of this statement is that right that much distance in the paper, whatever distance you see now, that much distance anywhere on the paper will be representing what? Will be representing 100 meters on the ground. That is the meaning. Okay. 1 second. 1 second. 1 second. Just a second. much distance anywhere on the map, okay, this much distance anywhere on the map will represent what? 10, 100 meters on the ground. Okay, so what they're trying to say is this much distance on the paper, on the map, right, is going to represent how much on the ground? This will be some x centimeters. This x centimeters on the paper is going to represent 100 meters on ground. That is the understanding. That is the understanding. So graphical scale is nothing but a line drawn on the map or a plan that is representing what? A corresponding distance on the ground. Okay, that is representing what? A corresponding distance on the ground. Yes. Now, what is the advantage of this particular graphical scale? The advantage of the graphical scale is that even if my paper undergoes shrinkage, the scale of the drawing will be preserved. Right. Let me explain this. Let me explain that point here. Okay. So, right. So imagine that you are having a map like this. Okay. Imagine that you are having a map here like this. Okay. In this map, let us assume that there is one engineer scale written. This is my engineer scale, and they're saying that this is say 0 meter and this is say 100 meters. What is the meaning? That this much distance on the paper, right, is going to represent 100 meters on the ground. Now look at this scenario here. I am going to give you a line here AB. I am going to give you a line here AB. AB is on the paper. I will say that length of line AB, length of this line AB is exactly equal to length of this graphical scale. Length of that line AB you see, that is exactly equal to length of the graphical scale. If so, tell me what is the ground distance capital AB? If small AB is exactly equal to the length of the graphical scale, what is the ground distance capital AB? Very simple, na? Ground distance capital AB, very good, Praveen. The ground distance capital AB is nothing but 100 meters. Yes. Now, what I'll do is, I will say that I am having one engineer scale on this particular map. I am having one engineer scale on this map that says 1 centimeter is equal to 10 meters. That says every 1 centimeter on the paper is equal to 10 meters on the ground. So, if I want to convert the paper distance AB to ground distance using this engineer scale, what should I do? Listen to that question again. If I want to convert the paper distance AB to ground distance capital AB using that using that engineer scale, 1 centimeter equal to 10 meters, what should I do? First and foremost, I should measure the paper distance AB. First and foremost, I should measure the paper distance AB like this using a ruler. Let me say I got this particular length as 10 centimeter. I got paper distance AB as 10 centimeter. So every 1 centimeter on the paper is 10 meters. Then 10 centimeter on the paper will represent what? 100 meters. Yes or no? Yes. So you see both of them, that is the engineer scale and the graphical scale, they are giving me the same ground distance. So I can say both of them are one and the same. Both that engineer scale and graphical scale are same only. Now what happens to my paper is, like this particular map, after some 10-15 years is, it will undergo shrinkage, right? The map or plan, whatever it is, we are making it on a piece of paper. After some 10-15 years, yes, definitely it will undergo shrinkage. What do you mean by shrinkage? It is nothing but reduction in size. Don't say reduction in volume, not RCC shrinkage. It is nothing but a reduction in size. Okay. So the particular map is going to reduce in size. So let us see how the maps looks like after some 10-15 years. So you can see that particular map has reduced in size. Okay. What will happen to this line AB? Will it shrink? Absolutely, no doubt. The line AB is also going to shrink. Right. This is my line AB after shrinkage. Similarly, what will happen to my graphical scale? Will it shrink? Yes or no? Yes. It is also going to shrink like this. It is also going to shrink like this. But the value written will remain the same. If this is 0 meter, this is 100 meter. It will be the same value. This will also shrink. Right. Now, listen carefully and tell me. Before shrinkage, length of line AB was exactly equal to graphical scale. Before shrinkage, length of line AB was exactly equal to length of the graphical scale. Now tell me, after shrinkage, will this length of line AB be equal to length of the graphical scale? Please say yes or no. Please say yes or no. Before shrinkage, they were equal. Once shrinkage has happened, will they be equal? Yes, absolutely equal. Very good. Very good. They will be equal, right? Because obviously shrinkage will happen uniformly. Shrinkage will definitely happen uniformly. Before shrinkage, if the two values were equal, after shrinkage also both values will be equal. Okay, please look here. Before shrinkage, both these values were equal. Uniform shrinkage has happened. So now also both of them are equal. Okay, now also both of them are equal. So now you see, in this graphical scale, what they are saying is, this much distance is representing 100 meters. This much distance on paper is 100 meter. Now this distance is equal to AB. Now tell me, as per the graphical scale, what is again the ground distance AB? The ground distance AB is again 100 meters. Because length of line AB and graphical scale are the same. Graphical scale are the same, therefore, again I'll get the distance AB as 100 meters. Now, tell me, after shrinkage, what will happen to this engineer scale 1 centimeter equal to 10 meter? Nothing will happen. It will just reduce in font size. So, it will only reduce in font size, and again it will say every 1 centimeter on the paper will be 10 meter. Now, how will I convert AB to my ground distance? Again, I need to measure the distance AB on the paper. Right. So, again, I'll take a ruler and again I'll measure the length of the line AB. You see, before shrinkage, AB length was 10 centimeter. But tell me, after shrinkage, will it be equal to 10 or will it be more than 10 or will it be less than 10? Bata? Please tell me. Before shrinkage, if AB was 10 centimeter, after shrinkage, will it be 10 centimeter? No. Right? Very good, Aditya. It will be less. Very good, Praveen. It will be less. Yes, very good. Everybody is saying the correct answer. It will be less than 10 centimeter. I'll get something like 9 centimeter. I'll get something like 9 centimeter. So now, as per that particular, engineer scale, what is my ground distance AB? Right? It will be, my ground distance AB is nothing but 9 centimeters into 10. Nothing but 9 centimeters or 9 into 10 meters. I'll get the ground distance as 90 meters. But tell me, is the ground distance of the line AB 10? Sorry, 90? No, this is wrong. Right? So this is correct. So tell me, once a shrinkage has happened, who will give you the correct scale? Engineer scale or graphical scale? Who will give me the correct scale after shrinkage has happened? Engineer scale or my, graphical scale? Clearly, the answer is graphical. Okay. So this is the advantage of graphical scale. Even if shrinkage is happening, the graphical scale will give you the same scale as before. It will preserve the scale of drawing, but numerical scales will not do that. Numerical scales will not be able to do that. That is the reason why in every important maps, we will have graphical scale. In every important map, we will definitely have our graphical scale. Okay, yes. So have you seen this graphical scale anywhere? Yes or no? The best example you can see here. Correct now. The best example of your graphical scale is nothing but your Google Maps. You can see at the bottom of your Google map, we'll be having something like this. Can you see this? What is this line drawn on the map or plan? What do you call this? You call this as your graphical scale. We'll call this as your graphical scale. Okay. Right. Yes, we will provide both. Manish, we will provide both. Engineer scale will be given as well as graphical scale will also be given. Both of them will be given. Right. Now, this is the best example of your graphical scale in your Google map. So, if have you observed, as you zoom in or as you zoom out, this particular line will readjust or the values will try to readjust. Why it is readjusting? So that the scale of the drawing is preserved. You can take your Google Maps in your phone after the class and check it. Even if you zoom out or zoom in, right, these particular values are adjusting. Why are they adjusting? So that the scale of the drawing is preserved. Okay, that's it. So these are the three different representation of the scale. What are they? Engineer scale, right, representative fraction, as well as our graphical scale. These are the three representations that we have. Right. So what is the advantage? Let us write down. What is the advantage of the scale? Advantage of the scale is that scale is preserved even after shrinkage. Scale is preserved even after shrinkage. That is the advantage. Okay, right. Now, when we talked about this particular engineer scale, we came across one very important concept known as shrinkage. We came across a very important concept known as shrinkage of maps. So what do you mean by this shrinkage of maps? Right, this is what we need to discuss. Okay, right. So shrinkage of map is nothing but reduction in size of the map. Okay, it's nothing but reduction in size of the map. Okay, we are getting a lot of numericals from this shrinkage of map, either directly or with combination of other errors. Error due to shrinkage, it will come as it is, or else it will be clubbed with some other errors. So you need to know how to work with this. Okay. So let us take a small example and try and understand. So you please imagine that I was having a line AB. Just imagine that I was having a line AB. When I prepared the map, for the first time, the correct length of the line AB was say 100 centimeters. The correct length of the line AB was 100 centimeters. After some 10-15 years, when I measured it, the measured length is coming as say something like 95 centimeters. So when I made this map for the first time, the length is 100 centimeters. After some 10-15 years, the length is coming as 95 centimeters. So tell me, did shrinkage happen here? Yes or no? Absolutely yes. 100 centimeter now has reduced to 95 centimeter. So definitely shrinkage has happened. To express the amount of shrinkage happened here, I will introduce a term known as the shrinkage ratio. I'll introduce a term here known as the shrinkage ratio SR, or shrinkage factor SF. Okay. And I will say for this particular map, the shrinkage ratio is 0.95. Right. And I'll say that for this particular condition I expressed there, the shrinkage ratio is 0.95. Can you please tell me how I got it as 0.95? Just tell me, how did I got it as 0.95? How did I got it as? Very good. I got it as 0.95 as nothing but 95 centimeter by 100 centimeters. Okay. Now, what is this 95? 95 is nothing but measured length after shrinkage divided by what is 100? 100 is correct length before shrinkage. So this becomes the formula for shrinkage ratio. What is the formula for shrinkage ratio? Formula for shrinkage ratio is measured length after shrinkage divided by correct length before shrinkage. That is the formula. But forget about the formula. Forget about the formula. Let us concentrate on this number 0.95. When I am saying that the shrinkage ratio of my map is 0.95, what is the value, right? Or what is this value trying to tell you? When I am saying that the shrinkage ratio of my map is 0.95, what is this value trying to tell you? Please understand, this value tries to tell you that your map is only 95% of its original size. Okay, this shrinkage ratio of 0.95, what it tries to tell you is your map is only 95% of its original size. I think you can agree, because at the beginning the line was 100, now it is 95. Initially 100, now only 95. So that is, the line is only 95% of its original size. Correct? This same statement, can you say in the reverse order? Please tell me. Can you tell me the same logic in the reverse order? The map is 95% of its original size means, what is the amount by which the map has shrunk? You can say that the map has shrunk by how much? 5%. Okay, so this is important. Right, this is important. So this understanding is also required for you. Right. So a shrinkage ratio of 0.95 is basically trying to say that your map got shrunk by 5%. So if the map is shrunk by 5%, what is my shrinkage ratio? 0.95. So the shrinkage ratio of a map can be expressed in two ways. Either they can give you the measured length after shrinkage and correct length before shrinkage. From that you can find out the shrinkage ratio, or else they will express the shrinkage ratio by saying statements like this. The map was shrunk by X percentage. The map was shrunk by 10%. Map was shrunk by 6%. Right? No, now you need to know how to get the shrinkage ratio. So please tell me, if the map is shrunk by 6%, what is the shrinkage ratio? If the map is shrunk by 6%, what is the shrinkage ratio? Please tell me. If the map is shrunk by 6%, very good, Dinesh. If the map is shrunk by 6%, shrinkage ratio is 0.94. Very good. Everybody correct. If the map is shrunk by 2%, what is the shrinkage ratio? Right. Very good. No, Sharavan. Not Sharavan actually. Who is that? Tushar. No. If the map is shrunk by 2%, it is 0.98. Tushar corrected. Right. If the map is shrunk by 2%, shrinkage ratio is 0.98. Tell me, the map is shrunk by 10%. What is the shrinkage ratio? Map is shrunk by 10%. Shrinkage ratio is nothing but 0.9. Very good. So this is how you can express shrinkage ratio. There are two ways. Number one, by saying measured length and correct length before and after shrinkage. Okay. Or else saying by the amount by which the map is shrunk by. Right. Now, please tell me something. If I give you a shrunk map, this is a map that is shrunk. So this is a shrunk map. In the shrunk map, if you measure a line AB, what will you get? In this shrunk map, if you measure line AB, will you get the correct length or will you get the measured length? If you measure it, what will you get? Measured length or correct length? You will get measured length only, no doubt. Map is already shrunk. So in this particular map, you are going to get what? The measured length of the line AB only. Now, if I provide you the shrinkage ratio, can you find out the correct length? Yes, because what are the data I am giving you? I am giving you the measured length after shrinkage and I am giving you the shrinkage ratio. So if you know these two parameters, can you find out the correct length before shrinkage? Yes, I can definitely find out the correct length before shrinkage. So tell me, what is the correct length before shrinkage? Right. What will be the correct length before shrinkage? Right. One second. By the shrinkage ratio. Correct now? Yes. Yes. So tell me, what is going to be my correct length? Yes. What will be the correct length? Correct length will be nothing but measured length of the line divided by the shrinkage ratio. That's it. We will extrapolate. What will be the correct area? Correct area will be nothing but measured area divided by shrinkage ratio square. Extrapolating. For every length, I need to divide it by shrinkage ratio. Area is nothing but product of two length. Product of two length means SR divided by SR divided by SR. So in the denominator, I will get SR square. What will be the correct volume? Correct volume will be nothing but measured volume divided by shrinkage ratio Q. That's it. Now, as I told you, once shrinkage has happened, your RF will not be valid because we discussed. Once shrinkage has happened, RF is not valid. So, how do you find out the correct RF? How do you calculate the shrunk RF? How do you calculate the shrunk RF? The shrunk RF, that means after shrinkage, if you want to use RF, the representative fraction in your map, what should be the representative fraction you should use? It is calculated as shrunk RF is equal to the original RF of the drawing multiplied with the shrinkage ratio. So these are the formulas for finding out the parameters. Okay. So based on this, there are some good questions in GATE coming. In fact, last year also we had questions from this area. Okay. Previous year, very recently also we had questions from this area. That's it. Okay. So these are the formulas. Okay. I hope you have copied them. Let us try a problem. I hope you have copied them. Okay. So let us look at a small problem here. Right. Please try and solve this. A plant drawn to a scale of 1 in 100 was shrunk by 10%. The revised RF is dashed. Very simple question. Try now. Any answers? Okay. Please remember, scale should be RF is always represented as 1 by n, 1 in n. Okay, not as 9 by 1000. Okay, please understand. You should always report the answer as 1 in n only. Okay, it's not in any other format. You cannot write as x by y. You have to write it as 1 by n only. Right. So let us look at the solution here. So what is the shrinkage ratio? The shrinkage ratio will be nothing but what? 0.9. Why 0.9? Because the map is shrunk by 10%. Okay. So what is the shrunk RF? They are asking you for revised RF. Revised RF or the shrunk RF. Shrunk RF is equal to original RF of the drawing multiplied with the shrinkage ratio. What is the original RF? 1 in 100 into shrinkage ratio 0.9. So if you solve it, you will get the answer as 1 in triple 1.11. This should be the answer. You should say the answer in this format only. Right. You should not write it as 1 in 1000. That is wrong. Yes. Harikiran, very good. Okay, so Harikiran has given me the answer in the correct format. Praveen, you wrote the answer as 9 by 1000. That is not correct. That is not correct. Because in your gate examination, they will ask you, the revised RF is 1 in dash. The device RS is 1 in dash. So that denominator you should write. So as per your calculation, what is the denominator you will write? 1000. Then the answer will be wrong. Okay, so you should write in this particular format only. They will ask you 1 in dash. Then the denominator you should write it as triple 1.111. That will be the correct answer. To write 1000 and all, it is wrong. You should know how to represent it in the correct form. Okay, so this is a very simple question, right, from this particular area. Right, now one other simple numerical we need to discuss is, another small numerical we need to discuss is, what is the error due to wrong state? Okay, so this is another discussion that we should have from this discussion or from this chapter, error due to wrong state. This is also, right, recently asked in so many PSU examination. In fact, 2 weeks back there was a Kerala PSC examination. In that Kerala PSC also, they have asked this particular question. Okay, so what is the error due to wrong state? Very simple model, but very easily you can go wrong. So please listen very carefully and try and give me the correct answer for the problem we will solve. Imagine that I am giving you a map. Okay, imagine that I am giving you a map here. Due to wrong state. So I am giving you a map here like this. Whenever I give you a map, what will be always given in the map by default? What will be always given? Scale. Map scale will always be given, no doubt. Any map I give you, together with that map, scale will always be given, no doubt. Imagine that there is a line AB. Right. Imagine that you are having a line AB. Okay, so you imagine that you are having a line AB on this particular map. Tell me, how will you calculate the ground distance capital AB? What is the procedure to calculate the ground distance capital AB? The procedure is, right, first and foremost, you measure the line AB, measure the line AB in the map, right, some excess centimeters you will get, use this map scale and convert the paper distance to ground distance. This is the standard procedure. Okay, you are having a map scale is given there, there is a line AB, how to calculate the ground distance capital AB? Procedure is, measure the paper distance AB by using a ruler, take the map scale, convert this paper distance to ground distance. This is the standard procedure. But what has happened here? You have used the wrong scale. That means instead of using this scale to calculate the ground distance, you have used some other scale to calculate that ground distance. Will I get the correct value? Absolutely not. Absolutely not. If you use a scale other than what is written on the map, you will end up getting a wrong value. That is the numerical here. If so, what is the correct length of the line AB? If so, what is the correct length of the line AB? So the formula goes something like this. The correct length of the line will be equal to the measured length into RF of wrong scale, right, divided by RF of correct scale. This is the formula. Okay. So the correct length will be equal to measured length into RF of the wrong scale divided by RF of correct scale. This is the formula for correct length. Let us extrapolate. What would be the correct area? Extrapolate, just like before. What would be correct area? Correct area will be nothing but measured area into RF of wrong scale by RF of correct scale, the whole square. Similarly, extrapolate once more. What will be the correct volume? Correct volume will be measured volume into RF of wrong scale by RF of correct scale, the whole cube. Understand? So this is the formula. Very, very simple. Nothing much to discuss here. So whenever you get a question from this, in fact, you will get a question from this, either in GATE or in ESC or in state service or in PSUs, you'll definitely get a question. Generally, they ask this, very, very commonly, right? Whenever you get a question from this area, what is your job? Your job is to identify who's the correct RF. Right? Read the question carefully from whatever I discussed and identify the correct RF. Once you identify the correct RF, you will definitely know who's the wrong RF. Correct? Now? Substitute, you should get the answer. That's it. Okay. So that is the a small numerical coming from this area. Very, very frequently asked question. Let us solve a problem here. I hope you copied the formulas. Let us try and solve the problem here. So please read this, try and solve this. Kunal is asking how much decimals. That will be mentioned in the question. Okay. If you have solved any previous year question, you will know that how much decimal point you should take. That is always mentioned in the question. There is no standard value for number of decimals. If you have ever solved any numerical answer question from the previous subjects you have completed, you will know it will be mentioned in the question. Any answer for this? Any answers? Okay, so there is no response from your side. No answers. Yes, Praveen has given us an answer here of 500 meters. So one answer is 500. Yes, Sharon is also giving me 500. Hari is giving me 125. Sri Shasta. Sri Shasta. Yes, Sri Shasta is giving me 500 also. So yes, Nanu Shri is giving me 125. So two options are 125. The remaining options are 500. Okay, so let us try and solve. From a plan drawn to a scale of 1 centimeter equal to 40 meter, the length of the line was computed as 250 meters. However, it was later realized that a scale of 1 centimeter equal to 20 meters was used for the computation. The correct length of the line on the ground is dash. The correct length of the line on the ground is dash. So this is the question. So please tell me who is the correct RF? Who is the correct RF? Please tell me who is correct. Right. 1 centimeter equal to 40 meter or 1 centimeter equal to 20. Who is the correct RF? The answer is 1 centimeter equal to 40 meter is the correct RF. Because read the statement. From a plan drawn to a scale of 1 centimeter equal to 40 meter. What is the meaning of that? The meaning of that statement is the scale written on the drawing is 1 centimeter equal to 40. As I told you, right? Whatever scale that is written on the map or plan, that is the correct one. You should use that. But what they're saying, instead of using that, I ended up using 1 centimeter equal to 20. That is wrong. So 1 centimeter equal to 40 meter is the engineer scale. 40 multiplied with 100, you will get the RF. That is the correct RF. And now, who is the wrong RF? Who is the wrong RF? 1 centimeter equal to 20 meters. Multiply that with 100, you will get the wrong RF. What is the measured length of the line? The measured length of the line is 250 meters. And what is the correct length of the line? Correct length is 250 into RF of wrong scale 1 upon 2000 divided by RF of correct scale, that is 1 upon 4000. So you will get the answer as 250 into 4 by 2, that is 2. The answer is equal to what? 500 meters. The answer is 500 meters. That is the idea. Okay, right. So that is your answer. Answer is equal to 500 meters. I hope this is clear. If you identify it incorrectly, instead of getting 250 into 2, you will get a 250 by 2, 125 meter. That will be given as option A. That will be given as option. Okay. So do not let that happen. Please read the data clearly. Whatever drawn on the plan, that is going to be your correct one. However, he is realizing that he used some other value to calculate the length. Clearly, that is wrong. Okay. Yes. So that is your correct answer. Okay. Yes. Yes. So that's it. We'll stop here for today. Okay. The last, I cannot start the next topic because we don't have enough problem. We discussed up to error due to wrong scale, and we solved one numerical also on that. Okay. So this was the discussion that we had in the last class. Right. So let us move on to the next discussion here. That is the different types of measuring scales. The different types of measuring scale that we have. Types of measuring scale. Okay. So what do you mean by a measuring scale? Just let me ask you. What do you mean by a measuring scale? See, measuring scale example is nothing but your ruler, your tape, chain, etc. Whatever instruments that we use to measure distances, that is what we simply call it as measuring scale. Right. Right. So the first type of measuring scale that we have is what we call it as a plane scale. Okay. So let us understand what is a plane scale. See, if you are having a plane scale with you, you'll be able to measure one particular unit. You'll be able to measure one particular unit as well as 1 by 10th of the same unit. You'll be able to measure one unit as well as 1 by 10th of that same unit. That is what we call it as a plane scale. Right. So it is possible to measure. See, two successive dimensions. Okay. It is possible to measure two successive dimensions. Okay. So that is what we call it as our plane scale. Right. So for example, if I want an instrument to measure in meters, it will measure meters as well as in 1 by 10th of a meter. Correct? Just 1 second. Just 1 second. Okay. Just right there. One second. So if you are using a plane scale, you will be able to measure two successive dimensions. You will be able to measure, possible to measure two successive dimensions. Right. So if I'm measuring, let us say in meters, I'll be having my plane scale measure in meter as well as 1/10 of a meter. What is 1/10 of a meter? We call it as decimeter. Similarly, if I want a plane scale to measure in centimeter, it will measure centimeter, and 1/10 of a centimeter is what? It is nothing but millimeter. 1/10 of a centimeter is nothing but millimeter. Okay. So if it is measuring in centimeter, it will measure centimeter as well as millimeter. Okay, that's it. So the best example of an instrument measuring in centimeter and millimeter is nothing but our ruler. In Nataraj, Apsara, camel scale you take, we have 15 centimeter, but each centimeter divided into millimeter also. Okay, so we have units in tens measurement, meter, decimeter, centimeter, millimeter, etc. Okay, so that is our plane scale. Now these are the standard plane scale we have as per IS 1491, 1959. Right. So as per this particular IS code, these are the standard plane scales that we have. There are 6 in number. So there are 6 plane scales. There are 6 plane scales, and they are named from capital A to F. Okay. So don't worry about this code here. Don't by heart the code and all. Not even for ESC, not even for PSU. You just remember about the number. How many number are there? You please remember. Okay. Previously, in Maharashtra PSC, they asked this number. How many number of plane scales are there? Yeah, so the answer is 6. Right. Now, why am I saying that you don't want to remember that code is because it is not civil code, it is actually architectural engineering code. Architectural engineering code. Okay. Right. So that's why I said you please remember the number only, that is sufficient. Yes. Now, the next type of scale we have is what we call it as a diagonal scale. So, if plane scale can measure 2 dimensions, diagonal scale will be able to measure, you see, 3 successive dimensions. You'll be able to measure 3 successive dimensions. Okay. So, what are the 3 dimensions that you have? That will be right. So what are the 3 dimensions that you have? That will be something like this: unit, okay, followed by 1/10 of the same unit, followed by 1/100th of the same unit. Okay. So unit will be there, 1/10 of the unit will be there, followed by 1/100th of the unit will be there. For example, if I want to measure in meters, it will measure 1/10 of a meter, that is decimeter, as well as 1/100th of a meter, that is nothing but centimeter. The best example of this instrument is nothing but our tape. Correct now? If you think about our tapes that we have in our survey, they are measured in meters: 0 meter, 1 meter, 2 meter. Right? Each meter is divided into decimeters: 1.1 meter, 1.2 meters, which is further divided into centimeters. So if I take a measurement with my tape here, I get a value like this: 12.85 meters. What is the meaning of this 12.85 meters? The length of the line is 12 meters, 8 decimeters, and 5 centimeters. That is the idea. So it measures in unit, tenth, hundredth. Meters, decimeters, as well as centimeters. Now, the codal provision for a diagonal scale is IS 1562, 1962, right? And there are how many? 4 diagonal scales. There are how many? There are 4 diagonal scales. There are 4 diagonal scales, right? IS 1562, 1962 suggests how many diagonal scales? 4 diagonal scales for us. Okay. Again, you please remember the number only. The diagonal scales are named from A to D. You can see here. That's it. Right. Now, the first 2 scales, that is the plane scale and the diagonal scale, they are measuring my distances. If you look at that closely, you realize they are measuring distances. Correct? Yes. Now, the third one that we have is what we call it as a chord scale. So, what will a chord scale do? They are used to draw and measure angles. So, whenever you are not having a protractor with you, you can measure and draw angles by using a chord scale. Okay. Whenever you are not having a protractor with you, you can measure angles as well as you can draw angles by using this particular chord scale. The fourth one that we have is what we call it as a vernier scale. So this is one scale that we have seen right from our childhood, right from our high school. In our 8th standard in our high school, we had something known as vernier calipers to measure the dimensions of a box, to measure the inside dimensions of a cup. We had vernier scale. Yes. Similarly, in our in the final year of our school, okay, intermediate or +2, we'll say, we have an instrument to measure the diameter of a wire. What is that instrument known as? How do you measure the diameter of a wire? By using something known as a screw gauge. Correct now? By using something known as a screw gauge. Okay. So we have used this particular verniers, right, since a long time. Similarly, in surveying, are you familiar with any instrument which is having verniers? Can you tell me? Is there any instrument in surveying which is having verniers? Can you imagine anything? Anybody? Yes, very good. That's correct. It is nothing but theodolite. So in our theodolite, there are total how many verniers? There are total of 4 verniers. Vernier A and B for my circular vernier, horizontal circle. Vernier C and D for my vertical circle. Yes or no? Yes. Okay. So there are in total about 4 verniers, right? So what is the purpose of a vernier? If you remember all of that, what is the purpose of a vernier? Please understand. Vernier is attached to the main scale to increase the accuracy of the main scale. That is the purpose. So what can I say? It increases the accuracy of the main scale. Right? It increases the accuracy of the main scale. That's it. Now, if you are using verniers for angle measurement, the maximum value you can get is 20 seconds only. Right? The least count of our vernier theodolite is 20 seconds. Yes or no? Yes. So that is the maximum value of an angle or the maximum least count for an angle measuring vernier that we have. But if you want to measure values less than 20 seconds, you have to use the next instrument that is known as the micro optic scale. Right? That is the next instrument. Praveen, raise your hands. Why? Accidentally. Okay, no problem. Yes. So if you want to measure angle less than 20 seconds, we have to use something known as a micro optic scale. So this is used in geodetic theodolites. Okay, it is used in geodetic theodolites. So when you are using geodetic survey, we need angles to be measured at a higher accuracy, right? Therefore, a higher least count, right? Better least count. So I use this particular micro optic scale. So it is used to measure values finer than possible with the verniers. Example would be in geodetic theodolites. Right? It can measure up to 1 second. It can measure up to 1 second. That's it. Okay. So these are the different types of measuring scales that we have. We need to discuss about vernier only. We need to talk about only vernier scales. Okay. So let us talk about the vernier scale here. Let us talk about the vernier scale here. So as I told you, what does a vernier do? Vernier will increase the accuracy of the main scale. But the question is, how does it increase the accuracy of the main scale? Like this is the answer for that. Vernier increases the accuracy of the main scale by measuring the fractional part of the smallest division marked on the main scale. What the vernier will do? It will measure the fractional part of the smallest division that I have marked in my main scale. Right. Let me try and explain that here. So you imagine you are having a main scale like this. You imagine that you are having a main scale like this. So you are having 1 centimeter length that is divided into right millimeter part. What is the value of each division here? What is the value of each division here? The value of each division here would be nothing but 1 mm. So no, the smallest division is nothing but 1 mm here. Okay, right. Now imagine I am giving you a line here AB. Okay. Imagine I am giving you a line here AB. Okay. Can you please tell me what will be the length of this line? You look at this. Okay. Okay. So this is my line AB. Can you please tell me what will be the length of this line AB? As accurate as possible. As accurate as possible. Can anybody please tell me what will be the length of this line AB? As accurate as possible. What is going to be the length of this line AB? Tell me, anybody? Right. So, yes, very good. So many are giving me the answer as, you see, AB is equal to 9.5 mm. Now, this answer is exactly or absolutely wrong. Okay. So many has given me the value as, like say AB is equal to 9.5 mm. So many of you given me the answer like this. But what I am saying is, this answer is wrong. Why this answer is wrong? Because initially we discussed that the smallest division S marked on the main scale is 1 mm. What do you mean by that? The meaning of that particular statement is that my instrument can measure only in the multiples of 1 mm. Understand? The instrument can measure only in the multiples of 1 mm. Understand? So that means after 5 mm, the next possible measurement with the instrument is 6 mm. After 6 it will be 7, after 7 it will be 8, after 8 will be 9, and after 9 you can only measure 10. You will not be able to measure anything in between 9 and 10. Okay. Okay, sorry. You will not be able to measure anything between 9 and 10. Okay. So when you are writing 9.5 mm, you are saying that there is a precision that is not there in the field. Such a precision does not exist in the field. Yes. So either what you want to do is, you want to say the length of the line is 9 mm, right? Or else what you can say is length of the line is 10 mm. But I will say both of these answers are also wrong. This is also wrong because clearly you can see AB is greater than 9. Clearly AB is less than 10. So that both measurements are also wrong. So in fact, this particular main scale is less accurate. This particular main scale is less accurate. Now when I attach a vernier here, what happens is the vernier will measure this fractional part. What the vernier will do? The vernier will measure this much fractional part. Right. So that fractional part I call it as X. So tell me, if the vernier is able to measure this fractional part, will I get the more accuracy, yes or no? Yes. So this is 9 mm. 9 mm plus X, that fractional part will give me more accuracy in my measurement. Yes or no? Yes. So that is the meaning of that statement. It will measure the fractional part of the smallest division marked on the main scale. Yes or no? Yes. Right. Now, depending upon how many number of divisions we have in our main scale and vernier, we have different types of verniers. Okay, this is the important discussion. Okay. Depending upon how many divisions we consider in the main scale, how much it corresponds to my vernier, we have three different types of vernier. Starting with first one, what is a direct vernier? Starting with first one, what is meant by a direct vernier? You see, for a direct vernier, the relationship goes something like this. For a direct vernier, the relationship goes like this. N divisions of vernier is equal to n minus 1 divisions of main scale. Right. This is the equation. I can write like this. N divisions of vernier is equal to n minus 1 divisions of main scale. This is the understanding. Okay. So let me further explain this. Okay. By taking a small example here. So let me take n is equal to 10. What is the meaning of n is equal to 10? It means that there are 10 divisions in my vernier. What vernier? The direct one. So if there are 10 divisions in the vernier, right, it corresponds to how much in the main scale? 10 minus 1, that is 9 divisions in the main scale. Okay. So when I write NV is equal to n minus 1 into S, the meaning is, right, the 10th vernier division. In this example, you see the 10th vernier division is going to coincide with what? With the 9th division of main scale. That is the meaning. The 10th vernier division coincide with the 9th division of the main scale. Right? 10th vernier division coincide with the 9th division of the main scale. Or I can say like this. The total length of the vernier. What is the total length of the vernier? 10V is going to be equal to what? 9 divisions of main scale. Right? Total length of the vernier means what? 10V. That is the total length of the vernier. That total length of the vernier is equal to what? Is equal to 9 divisions of your main scale. Right? That is another understanding. Or else I can say it in the reverse manner also. Right? Reverse manner also I can say that 9 main scale divisions are divided into 10 divisions of the main scale. 9 main scale divisions are divided into 10 divisions on the vernier. That is also another way of understanding this. Okay. So what is the relation for a direct vernier? The relation for a direct vernier is that NV is equal to n minus 1 into S. NV is equal to n minus 1 into S. That is the relation. Alright. So what are the different ways of interpreting this relation? Right. Let us see. Right. What are the different ways of interpreting this relation? Let us see. Right. So before that, let me take a small example here. So as per the previous example that we saw that previous scale. Yes. We saw here. Right. What is the smallest division marked on the main scale? S value you see. What is the smallest division marked on the main scale? That is nothing but equal to 1 mm. Okay. So if you go back to that equation, let us see how we can use this. Okay. So if S value is equal to 1 mm, right? What is the value of one vernier division? You see, 10V will be equal to 9 mm, right? Or one vernier division is equal to how much? 0.9 mm, right? So when the length of main scale division is 1 mm, what is the value of one vernier division? One vernier division you are getting it as 0.9 mm. Okay, right. So what I'll do is I'll try and show you like how this vernier will look in my main scale. Let me try and show you how this particular vernier will look in my main scale. Okay, so I'll remove all of this. Okay, right. So what I'll do is I'll take my vernier and attach this particular vernier on top of my main scale. So you can imagine that this is our main scale. So the first division of main vernier will coincide like this. Right. Now what is the value of one vernier division? Is it more than 1 mm or less than 1 mm? It is less than 1 mm. Okay. That is less than 1 mm. So what is that? That is the first vernier division. Okay. So you see, first vernier division. What is this? Second vernier division. Third vernier division. Fourth vernier division. Fifth vernier division. Sixth vernier division. 7. 8th. 9. 9 was too far. 8. What is this? 9. And you see, this is 10. Right. What is the last one? The last one is the 10th division. Yes. So tell me, where is the 10th division coinciding? You can see the 10th division is coinciding exactly with the 9th division of the main scale. The 10th division is coinciding exactly with the 9th division of main scale. Okay. Let us just number it so that you can have a small idea. Okay. So this is the first, second, 3, 4, 5, 6, 7, 8, 9, 10. So 10th vernier division is coinciding exactly with the 9th division of main scale. So that is the meaning of 10V is equal to, right, 9s. Okay, 10th vernier division is coinciding exactly with the 9th division of the main scale. Now, if this is equal to 9 divisions of main scale, if this is equal to 9 divisions of main scale, what is the total length of vernier? The total length of vernier is 9 mm. Correct na? If the 10th division is coinciding, that means the last division is coinciding with the 9th division of the main scale. What is the total length of the main scale? That is nothing but 9 mm. Understand? Yes. So this 9 mm is what we have divided into 10 parts. Okay. So these are the different ways in which we can understand that particular statement. When I write it as NV is equal to N minus 1 into S, there are different ways in which we can understand that statement. So the first way of understanding the statement is something like this. Okay. Please listen to this carefully. It means that nth vernier division, okay, coincides with the okay, n minus 1th division of main scale. N minus 1th division of main scale. Nth vernier division coincides with the n minus 1th division of main scale. Or what's the next division? Or next understanding? Total length of vernier is equal to n minus 1 divisions of main scale. That is the second understanding, right? And what is the third understanding? The third understanding is n minus 1 division of main scale is divided into n divisions of vernier. Which vernier? The direct vernier. N divisions of vernier. Right. Which vernier is that? That is for the direct vernier. Okay. So these are the discussions for which vernier? Direct vernier. NV is equal to n minus 1 into S. Okay. NV is equal to n minus 1 into S. So whatever I told you, I can show that here. So this is our main scale here. Okay. So this is 0 centimeter. This is 1 centimeter. What is the value of each division? The value of each division is 1 mm S. Now this is divided into how many parts? This is divided into 10 parts. Okay. So this is the vernier. So this is the first vernier division. Second, third, fourth, fifth, sixth, seventh, 8, 9, 10. Okay. So the 10th vernier division is coinciding exactly with the 9th division of main scale. The smallest division on the main scale is S. The smallest division on the vernier is what we'll take it as V. This is what we'll take it as V. Okay. Right. That's it. Okay. So this is how that particular direct vernier will go. Similarly, we have two more verniers. Let us talk about the next verniers. Right. I think whatever I discussed now, you can say the same thing here. Right. Who is the second vernier? The second vernier is retrograde vernier. What is the relation for retrograde vernier? I will tell you. What is the relation? You see, NV is equal to n plus 1 of main scale. Right. So n divisions of main vernier is equal to n plus 1 divisions of main scale. How can I write? NV is equal to n plus 1 divisions of main scale. This is the mathematical relation. Tell me the three statements for this. Okay. The three statements are the nth vernier division coincides with the n plus 1th division of main scale. Nth division coincides with the n plus 1 division of main scale. Next step. Right. N plus 1 divisions of main scale are divided into n parts of retrograde vernier. Next step. Third one. Total length of retrograde vernier is equal to n plus 1 divisions of main scale. Total length of retrograde vernier is equal to n plus 1 divisions of the main scale. Okay. So these are the three different ways of understanding. NV is equal to n plus 1 into S means nth vernier division will coincide with the n plus 1th division of main scale, or n plus 1 divisions of main scale are divided into n divisions of retrograde vernier, or total length of retrograde vernier is equal to n plus 1 divisions of main scale. Please understand. That is for the retrograde vernier. And one last vernier that we need to discuss is our extended vernier. The third vernier we have is extended vernier. So what is the relation here? NV is equal to 2n minus 1 into S. So how can I write it? N divisions of vernier is equal to 2n minus 1 divisions of main scale. It is equal to what? It is equal to 2n minus 1 divisions of main scale. N divisions of vernier is equal to 2n minus 1 divisions of main scale. Okay, please understand that. Okay, right. So again, the understanding is the same. NV is equal to 2n minus 1 means the nth division of the vernier will coincide with the 2n minus 1th division of main scale. The nth division of vernier will coincide with the 2n minus 1th division of the main scale, or 2n minus 1 divisions of main scale are divided into n divisions of vernier. Correct? Huh? Yes. What is the last statement? Last statement is total length of extended vernier. Total length of extended vernier is equal to 2n minus 1 divisions of main scale. That's it. Okay. So these are the three verniers that we have: direct vernier, extended vernier, and the retrograde vernier. What is the relation for direct vernier? NV is equal to n minus 1 into S. For a retrograde vernier, NV is equal to n plus 1 into S. For an extended vernier, NV is equal to 2n minus 1 into S. Please remember this. Okay, so these are the relations for the 3 verniers that we have. Now, the next term that is associated with our vernier is what is meant by least count. Okay, what do you mean by least count? See, least count LC is nothing but the smallest value that the instrument can measure. What is least count? It is nothing but the smallest value the instrument can measure. Okay, and the least count of a vernier is expressed by a relation S by N. Least count is calculated by using the relation S by N. Okay, so what is S here? S is nothing but smallest division of main scale, right? Smallest division of main scale. What is N? N is nothing but number of divisions of vernier. What is it? Number of divisions of vernier. Right, number of divisions on the vernier. Okay, so that is the least count. Now, what are the two models of problem that we can get from this area? What are the two models of problem we can get from this area? See, first model of problem will be something like this. Okay, they will give you main scale detail. They'll tell you vernier scale detail. Main scale detail they say. They'll also say vernier scale detail. Okay, they will ask you what is the least count. Can you calculate? Yes, simple direct substitution. S value given, N value given, direct substitution, you will get least count. That is the first model of problem. The second model of problem, what happens is, they will tell you the main scale detail. They will tell you main scale detail. They will tell you what is the required least count is. They will tell you what is the required least count is. They will ask you what is the right type of vernier, or they will ask you to design a particular vernier, direct vernier or retrograde vernier, whatever it is. So if you know S value and if you know the least count value, can you calculate N? Yes. Now for a direct vernier, what is the relation? NV is equal to N minus 1 into S. Substitute N here. If they ask you for extended retrograde vernier, NV is equal to N plus 1 into S. Substitute the value here. If they ask you for an extended vernier, NV is equal to 2N minus 1 into S. Substitute the value of N here. That's it. Substitute the value of N. This is how we'll get our values here. Understand? That's it. Okay. So these are the numericals that they can ask. Two models. To solve every numerical from this this area, you just need to know these two formulas. The formulas for our verniers and the formula for least count. That's it. If you know these two such a formula, you can solve almost every problem from our verniers. Okay, na? Yes. So let us take a numerical here. Let us try those numericals one by one. Okay. So please try and solve this problem. Please try and solve this. Read the question carefully and try and solve this. Okay. Okay, any answers? 0.5 degrees C. Okay. So you just report the answer in seconds for me. Okay. Yes. So the main scale of an angle measurement was divided into degrees and half degrees. So what is the meaning of that? So this is the main scale of my instrument. So this is 0 degree and this is 1 degree. This was further divided into half degrees. So tell me, what is the smallest value of your main scale? The smallest value of your main scale S is equal to how much? Half degree. Right. That is the S value. And it was attached to a vernier having 60 divisions. So what is the N value? N value is equal to 60. Then what is the formula for least count? Least count is equal to S by N. Okay. So what is S? S is equal to half degree, right? S is equal to half degree by N. Okay. What is N? N is equal to 60. Now, can you tell me what do you mean by half degrees? Like, what do you mean by half degrees? Can you tell me? Like, half degree means 60 minutes by 2. That is equal to how much? 30 minutes. 60 minutes by 2, that will be equal to 30 minutes. Right. Now, let us substitute that here. So, 60 minutes by 2, that is 30 minutes. 60 minutes by 2, that is equal to 30 minutes, divided by what is n value? N value is equal to 60. N value is equal to 60. So by 60. So what is 30 minutes by 60? That is equal to half minute. What is the value of 1 minute? 1 minute is equal to 60 seconds. 60 seconds by 2, what is our answer? The answer is 30 seconds. Our answer is equal to how much? 30 seconds. Okay. So I'm asking you to report the answer in seconds. Okay. Right. What is the answer? You should get the answer as 30 seconds. I hope you got the answer. 0.5 degree is wrong. Sarvan, very good. Okay. 30 seconds is correct. 30 seconds is correct. Very good. Okay. Kunal, what about least count? What about least count, Kunal? What about least count? Okay. Yes. So that is one direct model of problem where the main scale details are given, vernier scale details are given. You just need to do direct substitution. Yes. Look at this next problem here. Try and solve this. Okay. So any answers for this question? So the total length of an extended vernier, okay, the total length of an extended vernier was divided, into 119 divisions of main scale of an Abney level. Okay, Abney level is a handheld instrument. Okay, Abney level is a small handheld instrument. It will measure vertical angles, which we will use to calculate vertical distance. Level is for vertical distance calculation. If the instrument can read up to, can read up to 20 seconds. The smallest division in the main scale is equal to dash. The smallest division in the main scale is equal to dash. First and foremost, please tell me what is the value they are asking you for? What is the value that they are asking you for? 39.6 minutes, Ravi. Can anybody please tell me what is the value that they are asking you for? Yes, very good. Very good. Yes, that's correct. Kunal, Srikant, correct. Srikanta, Bhargavatega, correct. Okay. Yes, Manish, you are also correct. So they are asking you for the S value. So let us try and solve it. Let us identify the data. So what is the vernier that they are using? We are using extended vernier was equal to 119 divisions of main scale. Please understand what is the formula for our extended vernier. For extended vernier, NB is equal to 2n minus 1 into S. Now what is this 119? Please tell me what is this 119? Is it my Vernier division or is it on my main scale? This is on my main scale. Correct now? This is on the main scale. So is it n or is it 2n minus 1? 2n minus 1 is what they have given it as 190. Okay. So you see 2n minus 1 is equal to 190. So what is the value of n? 120 by 2 is 60. So the number of divisions on the Vernier is 60 divisions. The number of divisions on the Vernier is what? 60 divisions are there. Okay. Yes. Now the instrument can read up to 20 seconds. What do you mean by that? Instrument reading up to 20 seconds is nothing but my least count. Yes. Now, what is the relation for least count? Least count is equal to S upon N. Who is the only unknown? The only unknown is what? N. That's it. So, least count is what? 20 seconds is equal to, what is S? We need to find out. What is N? N is equal to 60. That's it. N is equal to 60. Right? So, please tell me the answer for this now. What is the value of S? What's the answer? 20 into 60 seconds. What's the answer? 20 minutes. Your answer should be equal to 20 minutes. Yes, very good. Right. That is your answer, okay? Manish says S is equal to 3. No, it's wrong. Okay. The answer is S is equal to 20 minutes. Okay. Right. I hope this particular problem is clear. Right. If not, then please try it once again. Okay, now, please take the question, try and solve it once again. Try to understand what is the data they are asking. Because there is only two relations. There is only two relations. Least count is equal to S by. Then comes the relations for the Vernier. For direct Vernier, N minus 1. For extended Vernier, 2N minus 1. For retrograde Vernier, N plus 1. Just remember that. So, these are the three parameters. S will be there, least count will be there, N will be there. These are the three things that they can ask. So, you can always solve it. Right? These are the three things that they can ask you. Two relations are there. It is very easy to remember. Okay? Yes. So, that is our discussion regarding the Verniers. Now, we will move on to our next discussion. Okay? That is what we call it as accuracy and precision. Okay, that is known as accuracy and precision. Okay, so this is two terms which are very closely related to each other. These are two terms which are very, very closely related to each other. They will ask you, is your measurement accurate? They will ask you, is your measurement precise? So we need to understand what is the relationship between this accuracy and precision. Right? When do you say a particular measurement is accurate? When do you say a particular measurement is precise? And what does they actually mean? To understand the concept of this accuracy and precision, what we will do is we will play a small game. What we will do is we will play a small game known as game of darts. You can see this. Okay, we are going to play a small game known as game of darts. Right. So this is the game that we are going to play. We call this as game of dart. So you can see that there is a dart board here. This particular board is what we call it as dart. Okay, and this game is known as game of darts, not game of thrones, not game of thrones, game of darts. So there is a board like this. There is a center point here. We will be having some arrows. I should throw the arrows and try and hit the center, bullseye. Try and hit the center of bullseye. This is what I need to do, right? So let us imagine that two people are going to play this game. Okay, two people are going to play this game. Who are the two people? First person is A, represented by the green color. Second person is B, represented by this orange color. So A and B are going to play. So who will throw first? Let us imagine that our player A is going to throw first. So he will stand some distance away from this board. He will take aim and he will throw. He is supposed to hit the center mark, but first time when he threw, let us assume he hit here. This is the first target of him. Okay, this is the first target of him. So he is slightly, away from the target. He is slightly below. He is not really happy. Okay, so what he'll do? He'll try and readjust his particular position. He'll try to aim slightly higher, slightly towards the left or right. He'll aim and then he'll throw. What happens? Let us assume this is the second target given by A. So he has adjusted too much. Okay, he went too much high. Right. So he is going to throw one last time, third time. So where he will make slightly more adjustment, slightly down he'll message, he will aim, slightly towards the left he'll aim and he throws. And let us assume that this is the third target. Okay, this was the third target. So these are the three targets of A. Now A is very, very unhappy because he has not hit the target. So the green color represents the targets of our player A. Now who will come? My next player will come. Who is that? That is my target player B. So B is represented by this red color. So B is very happy now, right? Because A has missed it. So now he will come to this particular same position, stands the same distance away from the board. He takes 3 arrows. He will try and hit this particular target. So he'll take aim exactly at the center and he throws and he hits here, right? So he's way away from the target. So he's like, okay, he's way away from the target. So now A is little bit happier because B is nowhere near the target. So B is little bit embarrassed. B again, recollects himself, takes aim, take a deep breath and throws. He is supposed to hit the center. Again, he hits this particular point. Okay, now A is very, very happy because B is completely missing the target. Okay, so B is under a lot of pressure. Under a lot of pressure, he takes aim one last time and he throws and he hits here. So that is the third target of B. Okay, so this is the third target of B. Okay, so this grouping represents the target of B. Right, now, please tell me from this example, who is accurate here? Who is the accurate person here? Is it A who is accurate or is it B who is accurate? Please tell me. How you multiply? Kunal, I'll come back to that discussion after this. Okay, I'll explain that after this. Okay, right. So who is accurate here? Very good, very good, very good. A is accurate. Who is accurate? Our player A is the accurate player, and who is the precise player? Obviously, if A is accurate, B is precise. Please tell me, why do you call A as accurate? What is the reason you called A as accurate? What is the reason you called A as accurate? Please tell me. What is the reason you called A as accurate? Very good, right? Because the targets of A are near to the the center point. Correct now? Right? The targets of A, wherever the positions of A we plotted, they are all closer to the target. That is why A is accurate. Then what is B? B is precise. So tell me, how can I define accuracy? Accuracy of a measurement is a closeness of the measurement to its true value. Okay, what is accuracy? Closeness to true value is accuracy. Then what is precision? Why do you say the targets of B are precise? You see, B is not close to the target, but all the points of B are closer to each other. So what is precision? Closeness of observation among themselves. That is precision. Okay, right. Closeness of measurement among themselves is what we call it as precision. So let me write down. What is accuracy? Accuracy is the closeness of observation, right, to the true value. Right. What is accuracy? Accuracy is the closeness of observations to the true value. Closeness of observation to the true value. Okay, yes. That is what we call it as accuracy. Now what is precision? Precision is closeness of observations among themselves. Is observations among themselves. Okay, that's it. So that is what we call it as accuracy and precision. Okay. So if I give you a chain, and if the chain is measuring, a line 3 times, all the 3 times, if I'm getting the same value, very, very close value, like for example, I'm getting 20.1 meter, 20 meter, 20.05 meters, 20.1, 20.05. What are these measurements? These measurements are what we call it as precise set of measurements. These measurements are what we call it as precise set of measurements. Understand? That's it. Now, if the chain, depending upon what is the condition of the chain, it may be accurate, it may not be accurate. Right? If the chain length is proper, then we may get an accurate measurement. But if the chain is too long or the chain is too short, you may not get an accurate measurement. Understand? That's it. So that is the discussion regarding accuracy and precision. Yes. Right. I hope that is clear. Now, our Kunal asked one doubt. Kunal, right? How you multiply? 20 into 1 minute is what? Whatever discussion we are going to have regarding errors, it is going to be fundamentally true for all syllabus of your examination, entire syllabus. Because even in for example in geotechnical engineering, they can ask question like this: if the drainage is changed from single drainage to double drainage, what is the error in the calculated time? Like that they can ask you. Okay. So this particular concept of error is very important for us. Yes. So let us try and understand what is an error. Can anybody tell me, when do you say error is present? When will you say error is present? Can anybody give me one small idea? When do you say error is present? Okay, so no response. So let me give you a small example. Imagine that there is a line AB, right? Let me say the correct length of the line AB is 10 meters. The correct length of the line is 10 meters, but when you measured it, the measured length is coming as 9 meters. Correct length of the line is 10, but the measured length is coming as 9 meters. So tell me, is there error present? Yes or no? Is there error present here? Yes or no? Yes. Machine error. Don't invent two things. Okay, is error present here? Yes. Yes. Very good, Bhargava, like Teja. So yes, there is error present. Why is there error present? Because measured value is not equal to correct value. Why is error present? Because measured value is not equal to correct value. So we can define error like this. Right? Error is nothing but the deviation of a measured quantity from its true value. Right. So whenever the measured value deviates from its true value, who is present? Error is present. Yes. Can you please tell me what is the amount of error here is? From this example, what is the value of error? Please tell me. What is the value of error in this example I told you? Right. Tanvi says 1 meter. Can you say the answer with the sign? Very, very important. Sign is very important. Is it plus 1 meter or is it minus 1 meter? That is the important question. Is the error plus 1 or is the error minus 1? Tell me. Right. Okay, I will say the answer. So please remember, error is always calculated as the difference between the measured value and the correct value. So please remember, error is always measured value minus correct value. This is how we will calculate our error. Error is always the difference between measured value and correct value. Error is always the difference between measured value and correct value. So if you follow that particular concept here, what is the error here? What is the error? Measured value is equal to how much? Measured value is equal to 9 meter, but the correct value is equal to how much? The correct value is equal to 10 meters. Right. So what is the error here? Error is 9 minus 10. You'll get the error as minus 1 meter. So that is important. Okay. Right. So tell me, if the error is equal to minus 1, tell me what is the correction is equal to? I think this you can say. If the error is equal to minus 1, what will be the correction here? What will be the correction here? Obviously, the correction is equal to plus 1. Yes, correction is equal to plus 1. So tell me, what is the relationship between the correction and error? Magnitude wise, they are the same. If error is having magnitude of 1 meter, correction also will have a magnitude of 1 meter. But if the sign of the error is negative, the sign of the correction is positive. So correction and error, they are equal in magnitude, but they are opposite in direction. Equal in magnitude, but they are opposite in direction. Right? Equal in magnitude, but opposite in direction. Okay, so please remember, correction is equal in magnitude to the error, but opposite in direction. Okay, yes. Finally, where do you apply your correction? Tell me, where will you apply your correction? Will you apply the correction to the measured value or will you apply the correction to the correct value? No brainer, na? Very simple question. You'll always apply the correction to measured value. Then only we'll get the correct value. See, we are trying to find the correct value now. But please remember, you take your measured value, to that measured value, you add your correction. Right? To that measured value, you add your correction. What do you get? You'll get your correct value. Okay, so please remember, the correction is always applied to the measured value to get the correct value. Right? It is always added to the measured value to get the correct value. That's it. So this is the concept of error. This is fundamentally true in all branches of engineering. This is fundamentally true in all branches of engineering. Okay, so please remember that. So this discussion is very fundamental and very basic for us. Okay, please remember that. Yes, just 1 second. That is the sources of errors. Right. So what do you mean by sources of error? Sources of errors means what are the different ways in which errors can come into our measurements. Right. The first source of error is natural source of errors. What do you mean by natural source of error? As the name indicates, these are errors that comes into our measurements due to the natural condition present at the time of measurement. What are natural sources of errors? These are errors that comes into our measurements due to what? Due to the natural condition present at the time of measurement. For example, you imagine this. I am giving you a 20-meter chain. You take this 20-meter chain and you go to your field. But in the field, the temperature is 50 degrees Celsius. Field summer is there. What will happen to my chain? the chain will slowly starts to get heat up. Correct now? Slowly the chain will starts to get heat up. And what happens to the length of the chain? The length of the chain will expand. So you are thinking that the chain is 20 meter, but actually in the field the chain is more than 20 meter. Whatever measurement you take now, that will be having an error. Right? That will be having an error. That particular source of error is what we call it as natural source of error. So I hope you can follow that. So due to the natural condition present at the measurement, they arise due to the natural conditions present at the time of measurement. That is what we call it as the natural source of error. The second one is what we call it as the instrumental sources of errors. So what do you mean by instrumental sources of errors? These are errors that comes into my measurement due to bad instruments. So I hope you remember the chain consists of links like this. The chain consists of links like this. Now if your friend comes and steps on this link, what will happen to the linker? The link will get bent like this. The link will get bent like this. The original length of the link was something like say 20 centimeter, but now the link length has reduced. So overall length of the chain will reduce. Okay. Using this instrument, if you take a measurement, definitely you will get an incorrect value. Definitely you will get an incorrect value. So they arise due to faulty or bad equipment. They arise due to what? Faulty or bad equipment. That is instrumental source of errors. And the third one is what we call it as personal sources of errors. So what do you mean by personal sources? Sources of errors, right? They arise due to the people involved in these errors. See, humans have certain limitations of touch, limitation of sight, etc. Some of us will find it very difficult to see which main scale division and which vernier scale divisions are exactly coinciding. When you are using verniers, we need to know where the main scale and vernier scale are exactly coinciding. Some of us find it very difficult to identify it properly, right? So if you don't identify it properly, yes, there is a chance of an error coming. Yes, these errors are what we call it as personal sources of errors. Okay, so they arise due to the people involved in the survey. Similarly, if you remember the example, when I asked you what is the length of the line AB, most of you told me the answer as 9.5 mm in that vernier discussion beginning. You gave me the answer as 9.5 mm, and I told you why that is wrong. Because the instrument can only measure in the multiples of 1 mm, but you wanted to be more precise and you assumed a precision of 0.5 mm. Okay. So these are due to what? As I told you, due to limitations in touch, sight, etc. Whatever error we get. That is what we call it as the personal sources of errors. Right. Now, please understand that the sources of errors are not important for us. Listen carefully. Sources of errors are not important for us because at the end of the day, if you want to correct it, if you want to correct an error, what do you need to do? You need to understand the nature of the errors. Corrections are provided based on the type, the nature of the error, not based upon the source of error. Please understand. More important than source, the type of error is important for us. The first type of error that we have is what we call it as a mistake. What do you mean by mistake? Tell me, when will mistake happen? Right? See, mistakes will come if you don't know what you are doing. Right? Now, if you don't have a clear idea of what you are doing, then what will happen? Mistakes will come. So, for example, when you started to learn, how to ride a bicycle, you made a lot of mistakes. Right? Now, right? When you started, when you are learning how to ride a bicycle, you made a lot of mistakes. Right? Because you don't know how to do it. Right. So as time goes on, you try and correct the mistakes. The more number of mistakes you correct, the more better you become. That's the idea. Okay. So they arise due to confusion in the mind of the observer. They arise due to confusion in the mind of the observer. Can I eliminate this mistake? Yes. Let us take a small example in terms of surveying. Okay. How are you supposed to hold the leveling staff? Do you know? When you go to the field, how are you supposed to hold the leveling staff like this? In between the two hands like this. In between your two feet, you should hold it like this. But how will you hold it? You will hold it like this. You'll hold it in one hand like this, and you'll say, "Hey man, you take the reading like that." You'll be very casual, right? So that can lead to mistakes because if your leveling staff is not truly vertical, whatever values that you measure, that may not be correct. Whatever values you measure, that may not be correct. Yes or no? So that is a mistake. Now, the important question is, can I eliminate this mistake? Can I correct this mistake? Absolutely yes. You can correct the mistakes. What do you need to do? You go and clear the confusion. You go and talk to your fellow that, we are trying to do leveling here, right? Be very careful. Hold the leveling staff like this. So if you eliminate the confusion, yes, you can eliminate mistakes. Yes, mistakes can be eliminated in the field. Now, the second type of error is what we call it as systematic or cumulative errors. Right. So what do you mean by systematic? What do you call, when do you call a person a systematic person? See, we call a person as a systematic person if he follows a regular trend every time. So he comes to your office at regular time, he does the work regular time, He comes back from the break at regular time, right? He'll do all of his work in the fixed time. Such a person is what we call it as a systematic person. Just like that, systematic errors means they will always follow a given set of rules. They will always follow a set of rules, right? For example, do you remember? I told you one example. You take your 20-meter chain to the field, and the field temperature is 50 degrees Celsius. So what is the reason? The chain is expanding. The chain is expanding due to the physical phenomenon of thermal expansion. Now, do we have a mathematical law for thermal expansion? Yes, no. What is the change in length due to thermal expansion? Alpha into delta T into N. So if I know the coefficient of thermal expansion of the material alpha, the temperature there, change in temperature delta T, and the initial length of the chain, I can calculate how much did the chain expand? Yes or no? Yes. So this error, thermal expansion, is a systematic error because it is following a physical law of thermal expansion, and we can follow a mathematical relation for it. That is what we call it as systematic errors. Now, what do you mean by cumulative? By the meaning cumulative is means to accumulate. So when I say that this error is cumulative, it means that this error keeps on accumulating. Keeps on accumulating. Please understand, it may accumulate in the positive direction or in the negative direction. Okay, that means if this thermal expansion error is positive in the beginning, all throughout the measurement it will be positive. If it is negative in the beginning, all throughout the measurement it will keep on becoming negative. Understand? So that is what we call it as systematic or cumulative errors. So they follow a definite physical or a mathematical law. They follow a definite physical or a mathematical law. Their magnitude direction remains the same for a given set of direction. Magnitude means their value, direction means their sign. Right. So wherever in the earth you go and keep your chain and apply the same delta T, always it will expand by the same amount because alpha is constant, initial length is also constant. Wherever you go and take the chain, apply the same temperature change of delta T, every time it will measure or expand by the same amount. That is why magnitude remains the same under the given condition. Yes. Now they tend to accumulate. Right? Either in the positive direction all throughout the measurement or negative all throughout the measurement. They will not jump from plus to minus. Understand? Yes. That is your systematic errors. Now the third error is what we call it as accidental, compensating or random errors. Please tell me, can anybody say when an accident will come? Can anybody say when an accident will come? Nobody can say. Nobody can say when an accident will come. What we can say is an accident may come, an accident may not come. What is the probability of getting an accident? What is the probability of getting an accident? It is 50-50. Right, there is chance of happening, not happen. So 50-50 probability is there. Will it rain today? Will it rain today? You cannot say yes or you cannot say no. You can say may rain, may not rain. Nobody can predict the weather. Okay. So it may rain or it may not rain. Understand? So the probability of raining is again 1/2. The probability of raining is again 1/2. So if you are using this approach to solve problems or solve errors, we call that particular approach as a probabilistic approach. So accidental errors are analyzed by using this probabilistic approach, which means we are going to use the rules of probability and the probability distribution curves to analyze it. Okay, probability distribution curves to analyze it. We cannot know whether these particular errors are present in my measurement or not present in my measurement. Right. So these are the three errors that we have. What is the first one? Mistake. First type of error. Second one is what we call it as systematic errors. And third one is what we call it as accidental errors. Right. I told you we can eliminate mistakes, we can eliminate systematic errors. So once the first two errors are eliminated, what is the only error left in the observation? That is accidental errors. This is one another way of defining your accidental errors. Yes. Why do we call them as compensating? Why do we call these errors as compensating? Because please understand, unlike my systematic errors, right, they will not remain with the same sign. Right? They will change their sign within the given measurement. That means first time this may be positive, right? Positive. Second time this may be negative. First time positive, second time negative. So total error is what? 0. So they tend to cancel each other. They tend to compensate each other. Therefore, we call them as compensating errors. Okay. So you see, they are random in nature. When they will come, nobody can know. Okay. They may accumulate in the negative direction initially, or in the positive direction for a given set of conditions. Right. And they should be analyzed by using the rules of probability and the probability distribution laws. Right. One last way is it is the error left in the observation after eliminating first error mistakes, second error systematic errors. Okay. So these are the discussion regarding our systematic errors. Okay. See, I will not discuss more about this accidental errors because there is chapter number 13 that is talking only about this accidental errors. Chapter number 13 talks only about this accidental errors. Right. One more point that I would like to discuss is please remember accidental errors are always directly proportional to square root of length of the lines, always directly proportional to square root of length of the lines, and your cumulative errors are always directly proportional to length of the lines. So these 2 points you remember. Right. Systematic errors are directly proportional to length, right? And your accidental errors are always directly proportional to square root of length. We will understand this as we move forward. Yes. So that is the discussion regarding errors. Now, since we are talking about basic concept, there are 2 more basic concepts that you should know when it comes to our survey. Right. The next topic that we should know is degree of accuracy. So, what do you mean by degree of accuracy? If I am saying that degree of accuracy of my surveying is 1 in 1000, what is the meaning? If I am saying degree of accuracy of my surveying measurement is 1 in 1000, what is the meaning of that? This particular statement tries to say that for every 1000 units measured, 1000 units measured, 1000 units measured, right? The error is 1 unit. There is 1 unit of right here. There is 1 unit of error. Okay, please understand. For every 1000 units measured, there is 1 unit of error. That is the meaning. Okay. When I am saying that the degree of accuracy is 1 in 1000, the meaning is that for every 1000 units you measured in the field, you are going to have 1 unit of error. That is it. Okay. So for every 1000 mm you measured in the field, you are going to get an error of 1 mm. For every 1000 centimeters you measured in the field, you are going to get an error of 1 centimeters. The general format of writing degree of accuracy is 1 in R. That is the general format. Degree of accuracy is written as 1 in R. Then the understanding is for every how many units? For every R units measured on the field, there is an error of 1 unit. Understand? This is also one concept that you should know. Right? Degree of accuracy. Okay, very small concept. Now, the last point that we need to discuss in this chapter is right the maximum allowable error in plotting a degree. Okay, this is a standard value. You may see this and you will see this multiple times all throughout survey. What is the maximum allowable error in plotting a degree? So you imagine that you are having a point here, say P. Imagine that you are having a point here, say P. You want to plot the position of the point P in the paper, right? If there is no error, this should be the correct position of the point P. There is no error in your work, point P should be plotted like this. Let us assume that there was a small error or there was some error due to which you have plotted the point like this. Is it correct position? No, that is the incorrect position. I will call it as P dash. So P is the correct position and P dash is the incorrect position. So if P is correct, P dash is incorrect, right? What is the P dash value? P is correct, P dash is incorrect. What is this P dash value? That is the error in plotting the detail, right? That is the error in plotting the detail. Now what is the maximum value of this error? The maximum value of this error is equal to 0.25 mm on paper. The maximum value of this error is 0.25 mm in paper. This is the standard value in survey. Please remember. The maximum allowable error in plotting a detail on paper is what? 0.25 mm. Okay. Right. So you see this. The maximum allowable error in plotting a detail on paper is limited to how much? 0.25 mm or 0.025 centimeters. Okay. This same statement is also written like this in survey. A good draftsman. Who is a draftsman? Draftsman is the person who will make the drawing. Correct? Draftsman is the person who will make the drawing. When will you call a draftsman as a good draftsman? When he can plot details within 0.25 mm or 0.025 centimeters. Okay. This is when I will call a draftsman as a good draftsman because he can plot my points within 0.25 mm or 0.025 centimeters. Okay. So this is the last basic concept that you should know in this chapter. Okay. So whatever points we discussed in this chapter now, that will be fundamentally applied, right, in the coming discussions. Okay. These are the basic concept of surveying. By knowing this, we can apply this in any other upcoming chapters. Yes. Okay. That's it. So let us do a small summary in this chapter. What are the topics that we discussed? So initially we saw the definition of surveying. Okay. Branch of surveying that deals with definition of surveying is art and science of expressing relative positions. What are the objectives of surveying? Three objectives are that to prepare map, to calculate areas and volume, to set out. After that, we discussed regarding the details of the earth, shape of the earth, objects, or okay. Primary divisions of survey, plane and geodetic survey. Primary classifications, which we discussed yesterday, based on the purpose of survey, based on the instruments. Yes, very important discussion. Next, what are the principles of survey? Work from pole to part. Location of a point with respect to a face, two well-defined point. Right. Next, we talked about scale, large scale, medium scale, small scale. Right. Types of scale, large, medium, small. Representation by what? Number one, engineer scale. Number two, RF representative fraction. Number three, what was number three? Graphical scale. What is the importance of graphical scale? Next, we discussed about error due to shrinkage of map. A shrinkage ratio of 0.95 means the map got shrunk by 5%. Similarly, we discussed about error due to wrong scale. This shrinkage concept, this wrong scale concept can be clubbed with any other models. It can be clubbed with any models where we are taking linear measurements. Okay, right. After that, we discussed about the types of measuring scales. After that, we discussed about types of measuring scale. Today we started that. Right. What are that? Plane scale, diagonal scale, etc., etc. We discussed. After that, we discussed about vernier in detail, direct vernier, extended vernier, retrograde vernier. And towards the end, we discussed about errors, sources of errors, types of errors. We discussed about the difference between accuracy and precision, small difference. And finally, degree of accuracy and maximum allowable error in plotting a detail. These are the basic concepts we discussed in this particular chapter. Okay, right. So that's it. That's the end of the chapter. So now what we need to do is we need to solve the problems. Okay. So can you give me an example of accuracy and precision? Okay. So you imagine you are given with a 20-meter chain. You measured a line first time, you got the measurement as say 40.5 meters. Second time you measured it as say 40.4 meters. Third time you measured it as say 40.49 meters. What are these measurements? These measurements, are they accurate or are they precise? you cannot comment on the accuracy. You can only say that they are precise. Why are they precise? Because 40.5, 40.4, 40.49, they are all very close to each other. They are all very close to each other. So since these measurements are close to each other, I can call them as a precise set of measurements. Why am I not commenting about the accuracy? What if this 20-meter chain is, say, too short, right? Too short. That means, right, there is some links that are bent here. Some links in the chain are bent. So the chain is not exactly equal to 20. The chain is not exactly equal to 20. The chain is less than 20. So you are thinking that the chain is equal to 20 and you are measuring it. But the measured values are very, very close to each other. Then that particular measurement is precise. But will that chain give me correct length of the line? Absolutely not. Because the chain is not correct. The chain is not correct. It cannot give you correct length. But the measurements are repeating. That means it is precise. I hope that is clear. This is the meaning of precision and this is the meaning of accuracy. So in general, we can only comment about precision. We generally cannot comment about accuracy unless we know more information about the measurement. Okay? I hope that particular discussion is clear. Please say yes or no. Who asked that? Manish asked that. Is it clear, Manish? Yes or no? Okay. So let us solve problems from this chapter one by one. Okay, solve this problem one by one. Solve it. If you have an answer, you please submit. Okay. Okay, so let us solve this. Okay, so they are saying that a plant represents a rectangular plot of land 63,500 meters square and measures 9.5 centimeter by 11.5 centimeters. What is the scale of the land? Okay, we solve a similar problem. So what they are saying is 9.5 into 11.5. This much centimeter square on the paper represents 63,500 meters square. Then what will every 1 centimeter square will represent? 63,500 divided by 9.5 into 11.5 meters square. Then what will every 1 centimeter represent? square root of 63,500 divided by 9.5 into 11.5. Right? This many meters it is. If you solve this, you will get the answer as 1 centimeter is equal to 24.11 meters. Get it as 1 centimeter is equal to 24.11. In RF, what is the RF? 1.2411. That is your answer. Okay. Right. Yes, very good. That is the answer. Try the next problem here. Solve this problem. So, a plan was drawn to a scale of 1 centimeter equal to 20 meters. Yes. On the same plan, a footing measures of size 6 cm by 9 cm. If the plan has shrunk by 6%, the actual plan was drawn to a scale of 1 cm equal to 20 meters. On the same plan, a footing measures of size 6 cm by 9 cm. If the plan has shrunk by 6%, the actual dimension of the footing in the field is dash. The actual dimension of the footing in the field is dash. So they are actually asking in the field, but if you look at the options, all the options are given in centimeters. So they are asking for paper dimension. So in the field you can cut. Like in the field value you can cut. Okay. The actual dimension of the footing is, that's it. So please try and solve this. Okay, so let us try and solve this. So, what is the shrinkage ratio? The map is shrunk by 6%. So, what is the shrinkage ratio? Our shrinkage ratio will be nothing but 0.94. Okay. Now, what is the measured dimension? We know now the correct dimension or our formula is correct length is equal to measured length divided by shrinkage ratio. Okay. So, I can write like this: correct dimension is equal to, what is the measured dimension? 6 centimeter by 9 centimeter. These are measured dimension. Each of them needs to be divided by the shrinkage ratio, 0.94. If you do that, you will get the answer as 6.38 centimeter and 9.58 centimeters. Okay. Yes. I hope you got the answer as option A. Yes. Very good. Aditya, the answer is nothing but option A. Yes. Try the next problem. Third problem. Third problem, please try. A digital theodolite is divided into degrees and 1/5 of a degree. It is fitted with an extended vernier and reads up to 0.01 degree. The number of main scale divisions are. Okay. So what kind of vernier we have? Question number 3. So we are having a divided into degrees and 1/5 of a degree. So what is the S value? S value is 1/5 of a degree. It is fitted with an extended vernier. So extended vernier means NV is equal to 2n minus 1 into S. That is the extended vernier. It is fitted with an extended vernier and reads up to 0.01. So least count is equal to what? 0.01 degrees. Least count is equal to what? 0.01 degrees. Okay. The number of main scale divisions are. So they are asking you number of main scale divisions. So what is the least count formula? Least count is equal to S by L. So 0.01 degree is equal to 1/5th of a degree by n. Okay. So 0.01 degree can be written as 1/100th of a degree is equal to 1 by 5 by n. Right. Right. So from this, what is the n value? 100 by 5, that is 20 divisions. N is equal to 20 divisions. But please tell me, what is n? N is nothing but vernier division. N is nothing but vernier division. Yes or no? N is nothing but vernier division. What are we trying to find out? We are trying to find out main scale division. So main scale division is 2n minus 1. So 2n minus 1 will be 2 into 20 minus 1, that is equal to 39. 39 is the main scale divisions. So this is the main scale divisions. What is my answer here? Option C should be the answer. Anybody got? Everybody, yes, very good, Sharwan Kanchi. Like the C is the correct answer. 20 is the number of divisions on the vernier. 20 is the number of divisions in the vernier. Okay, that is not the correct answer. Question number 4. The plan of a map was drawn to a reduced size such a way that a line originally 100 mm now measures 0.9 mm. 100 mm measures 90 mm. The original RF of the plan was 1:500. The revised RF is dash. We have tried the same model of problem in the classroom, but I'm not going to discuss this. You please go back, try it yourself. Move on to the next question, 5. Please try question number 5. Question number 4, we have tried one same numerical. So I'll leave that to you. You please try this. The length of 59 main scale division is taken as 1 over here. Okay. So you see, a theodolite circle is divided into degrees and half degrees. The length of 59 main scale division is taken as 1 over here. What's the least count of direct vernier? Okay. So divided into degrees and half degrees. So what is S value in the main scale? Half degree. Half degree means 60 minus by 2, that is equal to 30 minutes. Length of 59 main scale division is taken as length of direct vernier. So what kind of vernier we have? Direct vernier. So NB is equal to n minus 1 into S. What is given to me as n minus? What is given to me as 59? 59 main scale division. So that means n minus 1 is given to you as 59. So n minus 1 is equal to 59. Main scale division is n minus 1. So from this, what is n? N is equal to 60. What is the formula for least count? Least count is S by. So what is S here? S is 30 minutes by 60. So that will be nothing but 30 seconds. 30 minutes by 60 is half minute. Half minute is nothing but 30 seconds. Option C is the correct answer. Yes, very good. Kanchi. Yes, Aditya also correct. Yes, Bhargav Deva is also correct. By the next problem. The plan of a survey plotted to a scale of 1 centimeter to 100 meters is reduced in such a way that a line originally 100 centimeters now measures only 95 centimeters. The area of the reduced plan is measured as 810 centimeters squares. In the actual area, you see in kilometers squares. You want the answer in which unit? In kilometers squares. So please proceed. Okay, first part is easy. The calculation in kilometers squares is where you need to be careful. Okay, any answers? Okay, so let us try and solve this. So, what is the shrinkage ratio? Line originally measuring 100, now measures 94. So, shrinkage ratio is what? 0.9. What was the measured area? What was the measured area? 810 centimeters square. Then what is the correct area? 810 centimeters square divided by 0.95 d whole square. You will get the correct area as how much? If I'm not wrong, you get it as right 897.5 centimeters square. You get the correct area as 897.5 centimeters square. That is the correct area. But this area is in which you write a meter square. We don't want the answer in meter square. They want the answer in kilometer square. So here you need to take the help of your scale. What your scale says, every 1 centimeter on the paper represents 100 meters. We are trying to convert centimeter to kilometer units. So I will rewrite the scale like this. 1 centimeter is equal to 0.1 kilometers. Yes or no? 100 meters means nothing but what? 100 meters means nothing but 0.1 kilometer. So if every 1 centimeter is representing 0.1 kilometer, every 1 centimeter square will represent what? 0.01 kilometer square. Then 897.5 centimeter square will represent what? 0.01 into 897.5 kilometer square. That will come out to be as what? 8.975 kilometers. That will come out to be 8.975 kilometers. So now, yes, that is the correct answer. Option C. Correct answer is option C. So no, yes. So this is the easiest way of converting the unit. If you are comfortable with this, you can solve problems at very greater speed. Okay. Yes. Now let us look at the last question in this chapter. So look at this. Survey based on classification upon nature of field is R dash. So nature of field मतलब क्या है? Land, air and water. I hope you remember. Right. And land based surveys were land survey, city survey, topographic survey. So is number 1 counting? Yes. This is land or cadastral survey, hydrographic survey on water, astronomical survey on space, geological survey is not coming there. So these 3 are the options. So A, B and C. These are the options. So this is a multiple select question. You should select A, B and C. Then only full marks will come. If you only select A and B, 0 mark. Only select B and C, 0 mark. Only select A and C, 0 mark. If you select D also, you'll get 0 mark. There is no negative marking. Okay. The answers are A, B and C. Yes. That's it. That is our entire discussion regarding our first chapter here. That is basic concepts.